So before going further, we should know about all those. It's not working. It's not coming. Apple wants to. So we should know what you mean by drone. Next slide. So drone word comes from a honeybee. The honeybee makes and communicates with I think it's queen with other bees. So from there the drone word came from. But scientifically the name comes like dynamically remotely operated navigation equipment. So very few people must be knowing expansion of drone. That is dynamically remotely operated navigation equipment. That's what drone stands for. And there are many synonyms which is used by different people. One is called UAV, unmanned aerial vehicle, or unmanned aerial system, or also it is called remotely piloted aircraft system. So if you see in Google, all these names will be available. They are all synonymous to drones and UAV. And it is called unmanned aerial vehicle because it's an aerial vehicle without man to use remotely controlled. That's why it is unmanned aerial vehicle. Go to next slide. So, what are the basic principles of drone flying? That is based on the Bernoulli's theorem, Bernoulli's equations. That's what it works for. And any aerodynamics, any plane or any fluid dynamics, that depends on the Bernoulli's equations. And what it tells about is when a solid moves in a liquid, there is a pressure difference between the upper, between the and the down, and because of that pressure difference, then it will get lifted up. So that's what it says. So you can see when it moves like an aeroplane or anything, it moves, there is a pressure difference. So there will be high speed. If there is a high speed, then there will be low pressure. And there is low speed, there is a increased pressure. So there is a thrust always on the upward. That's how it will go up and up. So this is what the basic concept. This is what the Bernoulli's equations. Go to the next slide. So if you can see here, so that's what the high pressure is built up, low velocity airflow, and upper side there will be high velocity airflow. For that purpose, the dynamics has that design has been made for the propellers so that you make the pressure difference between the top and the down, so that the thrust is upward. And if thrust is more than the weight, then it will go up. For example, left hand side you can see that lift is nothing but the thrust going up. If it is more than the weight, then the plane will rise. If it is equal, it will remain stable. If it is less, it will go down. So this is what called the thrust or the pressure or the lift which is built up. So how to build up that thrust, how to build up that pressure, that's what the whole design is made of. And this is how the propeller design and everything is made. So this is what the basic concept of that. Go to next slide. So, so if you see, so the propellers are designed such a way that when it moves, it creates the pressure, turbulence, and the aerodynamics to create different kind of pressure. So when you have the important component of that is called the propeller, which is there like, for example, you can see the propellers here, and they have different shape, and they are the length of propeller is that's what the length from one corner to another corner. There is another command called the pitch. Pitch is if it is rotate, one rotation, how much is shifting upward and downward, that is what called the pitch. So this is what the specifications for the propeller. And you can see the dynamic, the kind of shape it takes so that it can create a air pressure for that purpose. Coming back to again classification of drone with respect to the rotors. So one is called the rotary wing, another is called the fixed wing. The wings, the propellers, how they are designed, how they are made. For example, you have an aeroplane, you have a helicopter. There is a basic difference, the flight and the helicopter. And you know what is the basic difference, what is the advantage and disadvantage of them. So same also here, in case of rotary wing, for example, you can see here, this is a copter which is having four quadrocopter. Quad means four, copter means four wings are there. So there will be hexacopter, there will be octacopter, like that you have. There are some which are the fixed wing. I don't have the picture right now here. For example, you can see here. This is a fixed wing, but I don't have the drone here, which is a fixed wing. So there are different purpose for both the rotary and fixed wing. Rotary one will be very slow and it will have vertical takeoff and landing. Like helicopter, it can take off vertical and take off, and landing will be also vertical takeoff and landing. But in case of plane, it has this runway to run through and again go for taking off. Before taking off, it has to run through. So same also in this case. In case of fish wing, there are different way of flying that. Either you can do by this, or there is a slider like this, or you can throw by hand or some pressure. So this is what the fish wing. But in case of fixed wing, what will happen is, for example, whole campus of IRE want to fly and capture the image. With a short time, the fixed wing can go around and fly and get the image done because it can go with a higher speed, with the high elevations, and the coverage is going to be more faster than what quadcopter is. But in case of quadcopter, what will happen is it can take up vertically and can stay over some time to capture image in more in detail in some area, which is very much useful for many purposes. For example, in case of crop health monitoring, you want to stay over somewhere in a defined area. In case of fixed wing, you may not stay over. It has to go. It can't stay over, so it has to run. But here, it can stay over. It will hover around whatever the area you are looking at and capture the image, and then you can get it landed. So this is what the basic difference. That's what is given there. And there is also another called hybrid mode where it is both the purpose it makes, like it will take off vertically, then go like a fixed wing, again it can land. So this is what the hybrid. Nowadays many UAVs are there which are hybrid mode. Then there is another principle also lies over here. When you have the motors in the wings, what happens when the blade rotates? So there is a force. And Newton's third law is every action has an opposite reaction. So that force that rotates, suppose rotation is anti-clockwise, then you will create a reaction that is your torque. So if at all there is only one wing like that, then what will happen is if it creates a torque, then it will fall down. So to balance that, so there is a down here, there is a tail rotor to balance that. So like you have a only monorotor in case of any drone, that's very difficult to manage because of this torque. It will make imbalance. So you have to be very difficult to balance that. So always you can see most of the copters are having two or multiple of two wings because to counteract that. For example, here you have a torque created to create anti-torque. Here there is another rotor here, right? So you can see here. So this is a quadcopter and this is a hexacopter. Like that, you have octacopter where you have torques created. For example, CW is clockwise rotations. So this is clockwise, this is clockwise. So this clockwise will have a torque anti-clockwise. But here, when you have CCW, then in this case, opposite directions, counterclockwise it was. So opposite directions torque will be created. Then all those things will be balanced. So this is what that's the reason why. So when you have a quadcopter, you will see there is a mark in opposite directions. So in the motor itself, so that you can put the same kind of propeller there. So they can move in the same directions. If you put by mistake something, then it goes wrong. So one has to be very careful. The similar kind of propellers should be there, and they are marked diagonally. They are marked different way. You can see when you go to the field. So whatever the drones we have, they are marked with which propeller will go where. Okay, so this is another principle. Then another principle remains is, as I told, you have to create a thrust, and the thrust should be such that it can go against the gravity and take up the lift of that. And usually for the drone to successfully flying, it should be 2:1. Thrust should be twice of the weight you have. So weight is the drone weight itself. Drone weight is all the accessories with its battery and also the payload. Payload stands for any sensor. Suppose you have a sprayer drone, then in that case it's a tank. So what is that? Altogether that calls weight. So the thrust should be like the total weight of the drone is 20. So then thrust should be 40 kg. Then it can take off. Okay, it should not be less than that. Then it may fall down anytime. So that's what has to be created. And for that purpose, you need all those pressure to be created. And while flying the drone, what are the possible directions? Because it's the air, is the air it is flying. So what will happen? There are three things happens. One is called attitude. The attitude is, you have your own attitude. So when satellite or any aeroplane or any flight on air, its movement in all possible directions is called attitude. Movement in all possible directions, it may roll, it may pitch, it may, understand the directions? So rolling, it may roll around itself. Another is notching around, that is your pitch, nose up and down. Another is called like in case of fish, the tail goes left and right, that is called YAW. All these three together, it's called attitude of the drone. Okay, is mentioned here with respect to heading because it's with respect to the directions, the angle it makes. So this is called attitude. Again, another point is called altitude. At what height it moving? So how many parameters are there? 4 parameters: roll, pitch, and altitude. So all those things can be controlled by your stick, by your remote controller. There are 2 sticks. When you will have the practically, you'll be able to see that. So they can be controlled by that. Which directions, which switch you have to, there are 2 switches. So which has to go up, which will go down while putting notch up and down, everything you can do by that. So you can see this is what the pitch, rolling, nose up and down. This is what rolling, and this is clear? Understood? Nose up and down is pitching. Okay. Roll is rolling around its own axis. Is horizontally moving left and right. Clear? So I think I should go to next slide. So what are the major components of the drone? To make a drone successful, these are the 5 parameters one has to take care. Then later we will decide as a user, what is that requirement for you and how to do that. So the 4 parameters are power, 5 parameters: propulsion, navigation, inertia measurement, management, and command and control. Okay. So the first one is the power, battery. So that is what the most challenging till now we have, how to make it more powerful, more efficient with respect to battery power. So what you need is, there are different 16,000 mAh 6S or 6-cell lithium polymer battery to run the motor. So there are different 11,000, 16,000, 21,000, 26,000 different mAh milliampere hours batteries are there, and those batteries are mostly called LiPo or lithium polymer batteries. And nowadays, the more efficient is lithium ion batteries are coming up. So recent drones, you'll see the lithium ion batteries, lithium polymer is taken up. And the challenge remains, the concern is lithium polymer is, if it is more than charge, more than its time, then sometimes it may burst. So we have to be very careful with respect to the temperature, with respect to carrying it. That's the reason why you are not allowed to carry a battery in your plane. Many times, very strictly denied to take the battery unless until there is an emergency or you are in for something for the cause of the nation, like you are in defense or something. So very difficult. They don't allow any polymer battery to carry on the plane. So, and 6S stands for, like 1S is 4.2 volt. 6 means 6 into 4.2. So that is something around 25.2 volt it comes around. And maximum gross discharge is per second, how much ampere it is going to throw out. That is what the discharge. And the weight of battery again varies. It may be 1.8 kg, 2 kg, it all depends. Okay, depending on number of cells, what you have. Then you can, based on the battery, your flying time can be decided. That will come to later. Again, you can, for example, here the battery weight was something around 1.8 kg, but you have a smaller drone. So in that case, you can have a smaller battery, then endurance or the flying time can be better. But again, the weight of the whole drone should be less. So you can optimize, you can trade off with respect to the weight of the battery and the endurance and the total weight of the drone. If you put a heavier weight, what will happen? Payload is getting more, weight is more, thrust will be required is more. For that purpose, all configuration has to be changed. So suppose it is 1.5 kg, 1.8 kg battery, then you can go down to 1 kg battery, but again, endurance time will be less. Endurance is the period of stay over the air is called endurance. How much time it can stay over. Then there are three things for which what happens, battery, the source of battery is only, source of energy is only the battery, but you have different components in the drone itself, which may require 5 volt, which may require 12 volt, which may require 25 volt. So for that purpose, there are different internal component which is used for that purpose. That is called battery eliminator circuit. What do you mean by battery eliminator circuit? Because for that purpose, for example, 5 volt, you don't need another battery. So that battery can be eliminated by a circuit that is what called battery eliminated circuit. That's a converter. Means 25 volt will be converted to 5 volt to give the power to your sensor. For example, most of the sensors you see here, they need only 5 volt. If at all it will supplied with 25 volt, it will be damaged. It will burn up. So convert to that. So that's why you have a BEC. You have sometimes you need a voltage converter, something around 12 volt. In that case, again, you have a BEC. And there is another called universal battery eliminator circuit, that is called UBEC, which you can dynamically keep on changing as you require. For example, you want to convert to 5, you want to convert to 12, you want to convert to 20. That is a way you can keep on changing, and then that can be dynamically keep on changing. That's what called UBEC. So there are three components with respect to power. One is your battery itself, then two components that is called BEC, which is inside again in the drone itself for the different power supply. So like in case of our drone, there's a thermal camera down there, which requires only the 5 volt. So that is connected through the BEC, so that whatever 25 volt is coming, that get converted to 5 volt and supply is done. Clear? Huh. Yes. How much is the weight of this? 1.8 kg. This is 1.8 kg. That's the maximum weight what you can get. And how much will be that total also? 2.5. So it is all different number of cells what you have, and accordingly it is decided. So heavy it is. How much weight of this? It is around 3.5 kg. Without that, that is stop. Just a little bit. Again,
Okay. Let's see. I have.
So then is the propeller, propulsion. So for that purpose, so that motor, which is there in the wing, and one is called ESC. So motor, propeller, and ESC. So this is the motor, and over there you have the propeller, and ESC is connected here itself with the ESC. So what happens is lossless DC motors. Again, there are different kind of motors available in the market, and those are mostly common now. E motors, and there is a model number written there, 5006. So there will be number like this. So 5006 stands for us2 digit is 50. That 50 millimeter is the diameter of that coil. You see that copper coil. That copper coil diameter is 50. So if it is 60, it will be more powerful. So this length is 50 millimeter. That's 5 centimeter. And next one is 06. 06 millimeter. All around you can see there's a magnetic field here all around. The thickness of the magnetic field that is 06 millimeter. So that is the model number, and that stands for that specifications. Okay, if it keep on increasing, accordingly the number model will be changing. And propeller has a fixed number again, 1806. 18 is the length of the propeller, and 06 is the pitch. I told about the pitch. If one cycle impacts, how much it will go up and down. And ESC is the electronic speed controller. That is how to control the speed of the propeller. That is what motor. That is what the controller is. So all these things, aerodynamics is happen. That's occurring because of different speed of the RPM you have in the propellers. You want to go to the front, then the pressure will be a different way. So then this propeller's speed will be different. So this is what the whole game is. So this ESC controls all those speeds. So there will be 4 ESC for each propeller to be controlled, and that's what centrally it is controlled by one unit called flight controller. So you can see here chart which is given over here. You see the motor name and the chart, and everything is given here. Throttle 40%, 45%, 50%, 55, 60, 65 like this up to 100%. I told you what throttle. So how much voltage it takes, how much current, power, RPM, torque, thrust, FPS, and efficiency. So what do you need is thrust. That is the weight, lifting, how much it does. So you can see at 100%, for example, around 2.2538. This many gram of throttle it creates. 2,538, and this is for 1. For 4 into 4. So same also here. You can see here 2, 9, and 6. It's around 3,000. Right? So that is 3 kg. 3 kg thrust it creates for one propeller, one motor. Then into 4 is going to be 12. So that's what the maximum thrust can be created for a motor like this with 100%. Right? So that's good. So now it is 3 into 4 is 12. So 12 kg. But what happens many times you don't fly with a 100% capacity. It's 80% we calculate out of that. So you have the weight of this something is around 3.5 kg. So your this is around 12 kg. So maximum weight you can carry is 6 kg. As I told, thrust by weight ratio should be 2:1. So if it is 12 kg, then maximum weight you can carry is 6 kg. But again, as I said, 80% of that you should calculate. So you may take it as something around 4.8. So you had 3.5, you have 4.8 kg minus it. How much it is now? 4.8 minus 3.5, it is 1.3 kg payload you can carry over. In addition to the weight of this, you can carry something around 1.3 kg payload. So you can think of whatever the camera you have, what is the weight, actually you can build it. So this is what the calculations is done. Suppose you want bigger, then accordingly the motor has to change, accordingly the propeller has to change, accordingly the battery has to change. Again, endurance time is different. That I'll come back again plan. Clear? Next slide. So there is another component called navigation and inertia management. This is again very important because it's a air it is navigating. So there are three things here. You have navigation, you have a GPS. So there will be two GPS so that redundant. By chance something goes wrong, then the other GPS will start working. And you have a inertia management. Inertia is accelerometer and gyroscope. The gyroscope accelerometer is detecting, measuring the acceleration in all three axes, like roll, yeah, pitch to control that. That's what it is, the accelerometer. And gyroscope is detect and measure the angular velocity so that it remains stable. And there is a barometer, which is again with respect to the pressure of air and altitude to understand how much height you can have. So putting them all together. So you have two things. One is GPS model with the compass. Compass is talk about the directions, and GPS is with respect to the locations where you are, and so that you can go do navigation as you like. And in the flight controller, all these inertia managements are there, and that is called the flight controller, which is there at the center. Clear? So this is a most important component again. If something goes wrong here, then drone may get damaged anytime. So this drone, the other drone, yesterday, my pilot Pratim was not here. Whole day he was busy because we had another drone where we lost the GPS connectivity. So drone was chaotic. So we got a company engineer, got repaired. So yesterday whole day he was in field, so he couldn't take the photography today. Yesterday we are looking for him. Next slide. Then last one is the command and control. That is your use your hand, whatever you have. Like you have so many remote RC here, remote controller. So that can be again is governed by what kind of remote controller you have, what are the capacity it has. So one is the radio control. What is the frequency at which it communicates to the drone? So there are different frequencies available. So if you see technical specifications of buying a drone or a spare drone, there are different frequencies people use, and that is what given. So we use here 2.4 gigahertz radio frequency to communicate between this and that. And many times you'll see these drones are not allowed nearby the airport because this frequency may create interference with the frequency they use in the airport. Then telemetry. Telemetry is radio communication between the ground station and the airport to share all the flight parameters. So that's altitude, speed, heading, GPS, everything. That's what the telemetry information you can capture. That's on the remote itself you can get it. Then the data link. All the data you can't directly upload and see over here in the remote itself. So many times what happens, you have a remote separately, you have a data link separately, like you have a mobile Android system or an iPad where you can see the images what is captured. But same time also in the same remote also you can have the everything, telemetry and data link and video transmitter also, like all the videos, images, whatever you can see. So all those things practically you are going to see today. Whatever we have a remote where you can get telemetry done, you can get video transmission there itself. You don't need another system to look for. Again, it all depends on the cost, how much it is. Go to next. So the last one is the airframe. The whole thing, it should be made of as lightest as possible because weight is the most important because you have to create a thrust, and each gram of thrust you create, you invest money on that. Battery, motor, all those things. So all those things should be carbon or resin, whatever the low weight material, it has to be built up by that. Okay, go to next slide. So coming back to the thrust and weight, I think I told you all about that. For example, 300, I told you 300 for the 100% throttle. So you have 12 kg. So total weight of the aircraft should be under 6 kg to make the thrust to weight ratio to 2. I told already about that. So, and this is what the weight calculations you can do. How much is the weight of motor? How much is the weight of ESC? What is the flight controller, remote air unit, battery, frame, and total weight? And mostly the dominating one is the battery. Rest is very less. Battery weight is 1.8 kg. You can see. Go to next. So now, the most important part is the endurance time. How much time you can, so you could know what is the weight you can carry. Now, how much is the endurance? There's a two key parameter for a drone to buy for. Okay. So how much weight I can carry, what is the sensor weight, and how much time I can fly. So how to calculate that? So for example, you can see here. So for example, your total weight was 3486 for 4 motor when you use. That is 3486, something around 87.5 grams. And if you look at that, how much is the current for that? You can see here. Three point 7.1. 3. We are looking at here. Yes. 18 inches. 18 inches. Achha, 18 is closer. 50%. Where is that? 50%. 3.67. At 50% throttle, that is 3.67. So that is what the current approximately requirement. And 4 motors, how much it will be? 14.68 ampere. And extra electronic takes 2 ampere current. That's the approximate calculation. So total current consumption is going to be 16.68. And your battery is 16 ampere hour. So divide that. How much it comes to? Again, 16 ampere hour. 80% you can go for consumption because at least 20% you should leave. You shouldn't go to the dead of the battery. Okay, up to 80% only you can fly. So you take 0.8 of that factor, that becomes 12.8 H. Then 12.8 divided by how much current required. So that gives you hour. That is 0.7673 hour. Multiply by 60, that gives you minute, 46 minutes. So clear? So from that chart, you come to know with 50% throttle, how much is the current requirement and what is the additional current requirement for you, 5 ampere, 2 ampere. Pull them together. Then divide with the 80% the efficiency of the battery. You will get in the hour, multiply with the 60 minutes, that becomes the endurance time. So endurance is around 46 minutes, that's 45 minutes with no payload. And if at all there is a payload, how much payload we can take? I told you, previous calculation 1.3 kg, then it can go down, 45 to, slowly it will go down, maybe 20, 35 like that. But without payload, it can fly 45 minutes. This particular drone, it can fly. So this is what the whole calculations you need to do. So there are two key parameters. One is the weight, how much weight you can carry on the payload, that you can calculate. Again, what is that endurance time? How much time it can stay over? That all depends on the battery, what you use and how much thrust is created using those motors, motor and battery. Clear? Go to the next slide. I think we have done this. So coming back to the remote sensing, I think we can skip this right now. We'll talk about the applications. Go to the next slide. So drone versus satellite remote sensing. This course is on the airborne remote sensing. So there are already satellite remote sensing. Yesterday you have heard many things with respect to satellite also and manned aerial vehicle also average sensing. So we have a special lecture on average sensing. We'll talk about manned aerial vehicle of NASA JPLs. So where again IRU was participating. So we have somebody from Space Application Center who is going to talk on what is that average sensing campaign, what we did in that. So anyway, so in case of satellite and UAV, you can understand what are the basic difficulties, what are the basic advantages and disadvantages. In case of satellite, what happens is, once it is launched, everything is fixed in the altitude, sensor, resolution, everything is fixed. In case of satellite. And again, it is not usual requirement point of view. For example, today there's a bright sunshine, I can take a satellite image of whole campus or whole Delhi. But yesterday or tomorrow it may be foggy, hazy, then you may not take. But tomorrow is an important day for you to do something on the field, to capture some image, but you don't have. You have to wait for again a sunny day to see. But by that time, the satellite is gone to some other place. It's not in Delhi itself. So, so the time is most important. Resolution is most important. The sensor is important. What sensor you require. For that purpose, satellite remote sensing, everything is fixed. So, but you have different kind of satellites. So you are looking at thermal sensor, there are satellites. You want only optical sensor, there are satellites. You want a hyperspectral sensor, there are satellites. You can look at them. But they are fixed with respect to the resolutions, sensors, height, and time of pass. So you can't change, but you have to change yourself according to that. That's what the difficulty. But in case of drone, everything is flexible. You can go outside, take the thermal sensor, height, come back, change the thermal, put the multispectral fly, change it, put a hyperspectral fly. So that you can do as you like. So you have everything on the same day, you capture all the images. Again, time is not an issue. Time in the sense, of course, the bright sunshine should be there, but time means if it is a weather is raining, you can wait for some time, maybe you can go after some time. Because the satellite doesn't possible. Again, the resolution. You can go up to centimeter level resolutions and very confined area, you can get a high resolution data as you like. You can go to more height, you can be coarse resolution, you can bring down to closer height, you can get a centimeter level data. So that kind of detailed studies you can do in case of drone. So sensor is flexible, flying height is flexible, resolution is flexible, area coverage also is going to be flexible. Again, so this is with respect to copter I am talking. When you talk of fixed wing, area coverage is going to be larger. Maybe bigger area it can cover. But disadvantages are many. Many in the sense, drone flying itself is a skill, expertise. You need to know, you need to understand all those things. You need to have a license for that purpose. Like nowadays, you need to have a unique identification number of drone, and also you need to have a pilot license with you. Because skill, like you are driving a bike or car, you need a license. Same also here, you need to go for a license from DGCA. Again, when you get the data, that analysis itself is not that easy. It's difficult. You need a specialized software to analyze all those data. Because again, drone, you are flying at different height. That altitude, everything is changing. In case of satellite, most of the things are fixed. When you capture the satellite data, the header information, everything is detail is given. And there are commercial software available where everything you can do automatically with respect to satellite. The software have designed, they have options which satellite data you are capturing automatically. You can see stitching and everything. Many things you can do easily. So that's what one point. Second point is satellite in a day you can cover whole country. Whereas in drone, you can't cover whole country. It's very difficult. We had a policy document of Niti Aayog we submitted long back, maybe around 6-7 years back. So around 2.63 lakh of drones you require in a day to cover whole country to take one-time image with the height of around 120 meters, that's the maximum height, and having capability of around 2 hours flying, something like that we have calculated. So is it possible to whole country to fly a drone to take one-time image? Being into drone, being into the agriculture domain, you need to look at the, like today you fly here, and same time whole country should be flown. You can think of how much time, and there it was 60 days it will take whole country to fly with. That many drones, with that much height, 60 days to cover one-time image of whole country. 60 days, everything is harvested. So that's not possible. So what happens is, so you can go, in case of drone, for a specific area, small area, you can do that. So whenever you need a larger area monitoring, drone is not a possible solution. For that purpose, you should go for satellite. And what you, so again, you have another sensor which you will go in the ground. For example, whole IRE, you want to go with a sensor, NDI sensor or green sticker, any, there are many sensors available. You want to monitor them, do the photograph. You can think of, you may take 10 days, 20 days to cover whole IRE. But whereas in case of drone, of course, you can do in 3-4 days or 5 days time, you can cover whole IRI. In satellite, within no time, you can cover. So drone is in between the ground data collections, whatever the limitations you have, and also whatever the limitations you have satellite, drone can be in between, bridging those gaps. So whatever challenges you have in the ground, for the smaller area, that can be taken care by drone. What are the challenges we have with respect to satellite, that can be taken care of drone. But nothing can be replaced by none. They are complementary to each other. Like drone cannot be replaced by the satellite, or satellite cannot replace the drone, because satellite can do in a larger scale. Wherever you see anomalies, some challenges, there you can fly the drone and do. And drone is a very confined small area you can do. For example, at a go, you have a large area of tea gardens, you have a coffee estate, you have a sugarcane, you have a grape, and you small of the some of those areas you want to capture the data. Then you can go with a drone and capture and do all. Whereas in case of satellite, you may not be able to do. But nowadays, you have many satellites having high resolutions, same as your drone, that can be also used. But again, the time when it is available, if it is cloudy, so there are a lot of issues. You want to have a thermal data. So accordingly, one can optimize when I can use drone, when I can use satellite. Both can be used for all the purposes. Okay, so that's the, like when you are doing a ground using a mobile platform, you have some limitations. So drone you can do very fast. Satellite, of course, again faster, provided its data availability is there. So understand those pros and cons. What is written over here. Next slide, Tarun. So I think I have told many of them with respect to ground-based, satellite, and manned aircraft and UAV. Those comparisons, all these slides is available. You are going to get in your pen drive everything what we are presenting. So don't worry to write down. So there are different applications for that. Go to the next slide. I should finish now. So since we are talking of a drone remote sensing, the sensor is most important. Again, the challenge remains is the weight of the sensor. What are the number of bands it carries? And what is the resolution I can get? And what height I can fly? As per the government of India rules, you can fly only at 400 feet height. Okay, so you can't go beyond that. So, and many times, so of course, we don't fly at 120, 130 meter. Most of the time, for the drone monitoring, for the crop monitoring, we fly around here in campus, 20 to 30 meter height. But people fly 50 meters, 60 meters, even 80, 100 meter height, they fly. But resolution will be very close. But here, for research purpose, we are doing each canopy, each leaf we want to see. So we go to the centimeter resolutions. So mostly SOP is what we developed over the time. We see around 20 to 25 meter height is the best to do that. So we started with the 10, end up with 60. We could see optimum height is something around 25 to 30 meter where you can fly with. So most of the data acquired, you can see what are the data we acquired, something around 20 to 25 meter height, what we have flown with. So these are different sensors which is available. So the local sensor is the RGB sensor. Most of the drone they come by default with the RGB sensor. Again, there are different kind of RGB sensor depending on the megapixel what they are capable of. So there are high resolution image data you can capture. Go to next slide. So sorry, no, previous that. So you have a most important cameras, multispectral cameras are there. So they have different bands. So they have a blue, green, red, near infrared, and red edge. So hold on for the time being. When you talk of the applications, I'll talk each of them and what are the possible applications because of the time constraint. Because we have to go to the field now. It is 10:45, so they have to take 20 minutes to tell you before going to the field. So I am hurrying up. So multispectral camera, we have different cameras again available in the market. We have a multispectral camera where you have 5 bands here. So this is the company name is called Vitas and Red Edge, and you can see here the camera is what you have. So 5 bands are there: blue, green, red, near infrared, and one is called Red Edge. And hold on, what is Red Edge? I'll explain when I take the application part. So nowadays, also there is this is one camera. So there is another company called Parachiqua where you have only blue band is not there. So green, red, blue, and red edge. So and we have another camera called Altum, where you have all these 5 bands. Again, there will be 2 dots. Thermal camera is there. Now recently they have built up with another camera. So you have all these 5 bands. Again, you have a very sharpened panchromatic camera, high resolution panchromatic camera. Panchromatic means black and white, but there is high resolution. So now they have come out with this is now out of function now, out of production now. because company has to make profit, do the business. So what they do is they put another camera with a high resolution panchromatic camera. So they say Mikasense P. Mikasense P is nothing but what happens is you have a high resolution panchromatic camera, you have multispectral with a low resolution. Both the image you can fuse and come out with a high resolution multispectral image. So that's in the software manipulation you can do. So for that purpose, they have hiked the price like anything. So it was costing me something around 5 lakh. Now it costs you 8 lakh or 10 lakh with that sharpened image. Of course, which is not required for me. Being an image processor, I don't need that. With RGB, I can do that. There is a way to do those. So anyway, so Ultim also, there are 7 cameras again. You have 5 here. Thermal is 6, 7 is the sharpened one. Clear? So this is what the latest development with respect to the sensors. You can Google, you can see Mikasense. Then the another is called hyperspectral camera. There are different hyperspectral manufacturing companies are there all around. So most of the companies they are manufactured up to 1000 nanometer. We have a hyperspectral camera here. You can see. Again, you will see all those things. And 23rd, 24th, you have a dedicated lecture for this. So I'm not covering anything about this. So people from US, from Europe, they are coming, talking to you all about this. So this is what the hyperspectral camera, and this is the camera is smallest weight in the world. They say it's 560 kg only. There are something called data recorder. That's why it looks bigger. Otherwise, it's only 560 gram per kg, and the range is 400 to 1000. Around 270 channels you have. So yesterday, Dr. Prakash Chavan was talking about RGB is 3 bands. Multispectral, you have 5, 6 bands. In case of hyperspectral, you have around 272. Yesterday, Salmi also showed some of the images. So 270 you have. So this is up to 1000 nanometer. So the information of what you used to get in the RGB, you get more information when you use multispectral. Again, more information you'll get when you have hyperspectral. So your purpose is to get more information, each specific range, how the different parameter you can characterize, retrieve. That's what the purpose. So hyperspectral, if you fly, you can get number of information so that you can go for discretion of the crops, you can go for discrimination of the crops, you can go for discrimination of stresses, you can go for quantification, any biochemical parameter also. All those things we are going to cover in one of my application classes. Clear? So, so hello? So much sound have come. Okay. Go to next slide. Then the thermal. Thermal again is single channel, but it is a thermal. It measures your temperature of the surface, the target what you have, and it has various applications. Most of the applications in case of agriculture, the precision is canopy temperature measurements and also crop water stress index and irrigation scheduling. So you can know within no time. Again, all those applications we are going to cover sometimes. We are going to have we have many thermal sensors available on the satellite, and we have a very dedicated sensors coming up very soon with ISRO and friends. Again, somebody is going to cover that when you talk about that's called Krishna. So that's mostly dedicated for multispectral and hyperspectral, having thermal ranges to capture many informations. Then another is the LiDAR. In case of LiDAR, you have a laser signal which you are receiving, by which you can do any detailed information about the morphologic parameters of any vegetation, any surface, like digital television, model or EMU or a generator, plant, morphologic parameters like geometry, height, number of leaves, and all those things. All detailed you can get by the LiDAR. Again, each class is going to be, LiDAR is, you have a special class for that. You will see the LiDAR sensor flying and getting the data and what are the possible principles. So I'm not covering detail of that. Go to the next slide. So these are the different available RGB cameras. Again, you are going to share with all. So you can see which camera you require accordingly you can buy. It all depends how much your pocket is allowing for that purpose. Go to next slide. So there are different multispectral and thermal cameras available. I was talking about the Mikasense or Parrot Sequoia, and nowadays, of course, I have not updated slide with what I said about the Mikasense P. That updates has to come up. But the weight is most important. You can see the kind of weight of the sensor what you have. Go to next slide. Then these are different hyperspectral camera. We are using a company called Headwall nano. Nano is the smallest camera. So there are many companies that are available, base spec, high specs, and many regional. And there are many companies available in the world. You can look at, but you have to see what is the pros and cons. The Headwell is the only company who has a whole range, 400 to 2500. We have up to 1000. We are in the process of getting 400 to 2500 2500 nanometer, the whole spectral range, what we can get. Go to the next slide. So, next. So, what is that suited for you? What is that you require? How much your budget you have? Accordingly, you can go for the buying the sensor. Thermal will give you only the can be temperature measurements, which is because of the stress. Stress may be because of water, and also sometimes because of the pest and disease, you will get the thermal. But again, multispectral, mostly drones, you can see the RGB kind of by default it is there, and the low cost you can get it. But when you have multispectral, you can use for deriving different indices, calculating them, and go for the crop health monitoring. All those applications, of course, we are going to cover some of the subsequent classes. But most important is, if at all you have a hyperspectral camera, you have everything on your plate. You can eat anything as you like. So it's like a South Indian thali. So it's not those sides, everything is there. So you can eat as you like. So go to next slide. So these are what different sensors what you have. Again, another sensor I didn't talk about is the microwave radiometer. We are again the process of getting microwave sensor. Hardly anybody is having. Even if hyperspectral, also very few organizations they have hyperspectral with the airborne. So that's what this is unique with this training, this facilities. We have that hyperspectral. We developed all protocols, methodology, how to retrieve, how to get those informations for agriculture. So RGB, thermal, microsense with radius, parallel stripper, ultim, hyperspectral, LiDAR, micro radiometer. All those you can use for different purpose. And main purpose is how to get the information what you require. For example, Shubhi wants the number of passes to count. So you fly with the RGB camera, you need to go for thermal, you don't need to go for the multispectral. Simply RGB, you can know number of pumps in the mix. Those classes will be taken later. Yesterday she covered the big data analytics. So how those big data analytics can be used to retrieve quickly, automatically different information, which otherwise is going to be difficult. Those things we are going to cover altogether separate time. Go to the next slide. Next one. So these are the different drones which is available again in the market. But the challenge is nowadays it's discouraged to get any outside drone. Government of India policy. So most of the in-house drones you have to buy means make in India the startups and industries what they have. So you have to see what are those available in the market. Last day we have since you are here, maybe tomorrow the students and young researchers you would like to work with, you will go as an intern and to work with them. Last day we have a workshop. Many industry drone industries are going to be here. They will be talking all about what they have and how they are going to how they are working, what are the challenges. So you'll interact. That's the purpose why we kept it. And from them also we try to learn what research area we should address to. Go to next slide. So I think I shall finish. Go to next. So this is what we have with us in the lab. Again, soon you will visit the lab to see what are the drones we have and what are the sensors we have. So, and this is what the lab, big data analytics lab and drone remote sensing lab we have. And we have also developed data analytics for the hyperspectral data. What you have tomorrow, you have some class since morning till evening on the hyperspectral. Tomorrow we have non-imaging spectral radiometer, right? So that is what the second window tells how to analyze that software automatically. We have developed our own methodology, more own software, and drone data analysis. You fly the drone within no time, you can get the drone data analysis here that we have developed in-house. All those things is going to be covered by Dr. Tarun and Dr. Salini subsequent classes. So go to next slide. So this is what 2016 I itself yesterday I was mentioning. Honorable Chief Guest, what we have Dr. Mahapatraji. So in 2016, we showcased to the Honorable Prime Minister about the drone technology for agriculture. And that time we didn't know much about drone or the sensors. So we are working together with the Delhi Technological Universities. We had another program on which we were working. So we developed an in-house drone and showcased them. And again in 2018 also again he visited Prime Minister again for the soil health. So we'll come back that applications, what are the
possible challenges, what are the success stories we have with respect to drone applications for crop and soil health monitoring. And this is recently, last February, Honorable Minister of Agriculture, State Minister, Mr. Kailash Chaudhary, and the whole team of ICS, they were here. And we had some policy document with respect to technology for crop insurance, and drone is one of the key factors for crop insurance. And recently, again, ROF is here from agriculture engineering. We have IRA team has contributed a lot with respect to policy document with respect to pesticide applications, liquid fertilizer applications. I think that's what the last slide is. Any question you have? If we move to 20 minutes, my team is going to talk before they go to the field how to go for the mission planning and what are the criteria you should take care of. So in case of drone remote sensing, one part I forgot is the resolutions, at what height I should fly and what time I should fly. You should remember the light is most important source. So what the light condition at which I should fly. If it is hazy, you will get an image, but it is meaningless for you. So today it is hazy, tomorrow is bright, so you won't be able to do anything. Comparison if you want to do. So light condition is most important. At what I should fly, because what is that area, what is that pixel size I want, ground resolution. So there is a calculations for that purpose for different sensors. So again, tomorrow the engineer is going to talk about that. If he doesn't cover, then in my applications I'll cover how to calculate ground resolutions, ground spatial distance, GST. That based on that you can fly at different height. What is that area you want to cover? Again, so the area should be covered. Like for example, you will be flying somewhere in 5-acre land, and the timing depends on the battery power what you have. So the drone automatically how much time it can take if at all this area when you go for mission planning. So you have a 20 minutes time. So again, 20 minutes time you have to fly full 5-acre. Imaging has to be done very slowly, one by one. Again, suppose it's not covered in 20 minutes, it says 25 minutes, then you can go to bigger height. So that area cover is larger and it finishes within 20 minutes. So that decision one has to take when you go for the mission planning. What is your endurance time? What is the battery power left after fully charged? One must be very careful. Checklist, you should have a tick in the sense fully powered. You should be go with the sunglass. You should checklist with respect to calibration panel. Many things are there. You should go to the field. If anything goes left in the lab or in the room, you go to the field. Then again you have to come back. One to be very very careful while flying those and see everything is calibrated, properly charged. Because in the field you don't have a charging stations, and you should have a spare battery, and you should have a calibration panel to with respect to light conditions how to calibrate. So all those things should be, you should checklist, do it, and go to the field and do it. So this is all about. If at all any one or two questions, otherwise I'll ask my team to take over. Yes, ma'am.
So do we have an autopiloting sort of drones?
Resolution depends on the height at which you fly. So, Tarun, you can close it, put your slides. So tomorrow is going to come up images for meetup. So the company guys will come. So this is what suppose sensor is here, and this is whole thing is called FOV, field of view, and each sensor has a field of view. You should see the detail of that sensor. Go to the website, see what is that field of view. So, and if you are on the top like this, you have a area coverage. This is what the area cover. And suppose I take this as a circle, not an elliptical circle, and this is what the radius, and this is what height at which you have. So this FOV is, suppose I said theta. So this is going to be theta by 2. So tan theta by 2 is going to be r by h. R is your radius, h is your height. So your r equal to h into tan theta by 2. So whole thing swath that is equal to r equal to nothing but 2h tan theta by 2. So now you understand. So your ground resolution, that is 2R, is depends upon the height and field of view. Field of view is the sensor specifications. Thermal camera will have field of view different, multispectral will have different, RGB will be different. Again, height and R, they are inversely related to each other. Clear? Okay. So I am not pretty sure whether the bus is arranged. Huh? Yes. So just today we are going to do autopiloting only. Manually you can do, but everything is autopilot. That's what he's going to show you. So you just ask him to wait. See now what we are going to show you in the video. Okay. So now what we will show is, before we go to the field, we need to do mission planning. And there are mission planning softwares are there, free and also commercial softwares. Both is going to cover. And so
the slide is not shared, so kindly share your slide so that we can able to.
Ready.
We have planned to invite
Hello.
far from here.
Hello. Check. Hello.
We are arranging that's why otherwise you just go outside. Do the engaging so images what we are taking the field. So that's what we are planning. So you need a is taken in the remote sensing applications for the water quality monitoring from people like he has been working with us again almost more than 1 year now on the data analytics and Google data processing. Then within we have a team like Mr. Pratim. Pratim is pilot, so you see that it's made by him himself. So everything is assembled here. We have stored all those components and assembled, and he is going to fly and show you all those details. So both of them are going to take over. We have Mr. Vishal also, who is with them again helping. And hyperspectral data processing, yesterday you heard of Dr. Salmi. I have Dr. Rejit this random, so that they should know from our team. So Dr. Rejit again is a hyperspectral expert. He is in imaging spectroscopy applications. So he is developing all those analytics. So he was ill just only yesterday. He came back from home. So that's why I have the team again. Engineer Rahul, who takes care of all the engineering aspects. I have another huge facility when time permits to go. We have an energy dynamic center. We have all kind of camera there. And so he was having all those experience since beginning till now. He has been involved in that. So starting from sensor to automatic imaging and everything. So I think anybody here from my team, I don't know. So this is all about the team, and of course there are many. They are outside now. So I'll ask Tarun quickly. You should finish as quick as possible.
Okay.
We should be break for tea and 11:30.
Sure. Okay. Thank you so much, sir. So hello everybody. So here we will show you a small video about how to do live video. Programmed video drone data capturing. So first thing is, the most important thing you have to understand when you plan a drone mission is you have to make sure that whatever happens to the drone, it comes back safely to the point it took off from. So that is called as updating the home point. So first you have to say the drone, you have to take the flight from this position, and if something goes wrong, come back and land here only. So that is called as update the home point. Okay, and also you need to check whenever you launch a drone mission, you will have a tool like this thing, okay, remote like this thing with a stand and to put a screen here, okay, or else you can handle the screen in your left hand. So you will have any device like this, Android or iPad, but in that thing, we right now we are showing you what Sir has explained, Phantom 4, which is from DJI. It has an RGB sensor. And next part, I'll show you how to program for a PX4 based drone. So here, when you launch a mission, first you need to check what this is the overall status of the drone. So it is in a normal status, good condition, and also it also gives you at which mode it is flying. GPS mode. There are three modes. One is GPS, where you don't have to do anything. The drone will actually use its own GPS locator to position itself. So it is very easy to fly the drone. Second is loiter mission or altitude mission, where you will have to control as a user. You have to control the drone. Okay, the GPS will be off. The third thing is return to the home point mode. Okay, so that is what right now it is in the GPS mode. It is a best mode for mission planning. Then you have to. This is the what Sir was telling. That is 120 meters. So this is the maximum height at which a drone can be flown in India. It was set by the government. So, but generally we have to keep it as 100 meters so that to have a leverage and to avoid the obstacle. This is a very important option. So whenever you plan, make sure that this option is set according to the regulations. Then this is what controls the drone's pitch, roll, and yaw. So this is a compass to control the direction as a northwest east, and then this is IMU, inertial unit. So here it controls the pitch and roll, So you have to be make sure that this is functioning normally in any drone. Then comes this is what powers the system. So you have to make sure that this is normal. So these all options basically tell you how the drone is functioning before the mission. So you have to make sure that everything is normal and good. Then next part is you can also see the live feed. The screen is actually giving you the live feed from the sensor. So this is very important. And for DJI Phantom 4 Pro, we use a application called DJI Go 4. Okay, Go 4. In that, see, we are trying to update a home point here using this option here. First thing is you do is update the home point option. So next is that, sorry. Yeah. See, we are updating the home point option. Once a home point option is updated, you will get a notification that the home point is updated. Now, for mission planning, we will use a different software called as Pix4D Capture. That is a Pix4D Capture. We use that. So here, the drone, the software automatically identifies the drone as Phantom 4 Pro, and then you go into the mission mode. And here you can see all the units, maps, which type of, and these are the grid types. So you can use any of these grid. Right now we are using a square polygon. So here, what does it do? You just choose an area. Okay, this is my field, and then you use the four corners as the the boundary, and plan a gridded flight path. So that is what this is. The lines you're seeing here is the path in which the drone will fly and capture the data. And you see the dotted line above and below. This dotted line will make sure that the drone doesn't capture the data when it is transitioning from one line to the another line. Okay. And here is what you see, the altitude. You set the altitude at which the drone is flying here. This is very important. Four things are very important when you are trying to do this kind of mission. First thing is the home point. Second thing is the first point at which the drone will go and start the mission. That altitude you have to set. Second is the altitude at which the mission is being done. So that is very important. Third is once the drone finishes the mission, it reaches the end point and comes back. That is one altitude. So you have to set four altitude. Here you'll only set one or two, because this is DJI, it is already programmed inside. But for PX4, you have to set four altitudes. Okay, this is very important. And based on this, if I change this option here, even the GSD will change. Okay, this is what Sir was explaining you here on the board. This will determine the pixel size yesterday Dhakar sir was telling you the pixel size, right? So that is here GSD. So when you are flying the drone, make sure that you are flying at an optimum altitude and the GSD is appropriate for your mission. So now the Pix4D is connected to the drone. It is showing here. Pix4D would like to use Bluetooth. So you are using the Bluetooth to connect to the drone now. Okay, you're communicating with the drone immediately using the. Then, okay. So now I would like to explain this part here. So this is the position of the drone. We are on the field. The drone has GPS, so it identifies itself and the positions itself on the screen. Now you see here the two red dots here. These are the front side of the drone, and the green is on the back side of the drone. So here you identify the field based on the position of the drone. So you put the drone on the ground, and based on the position of the drone, you identify the field, and then you plan the mission. Always. See now, earlier it was 1.8. Now the flight mission is 30 meters. The GSD has changed automatically. And also, when you plan a mission, you have to always keep a note of this. So this is your drone that you are using. This is the camera that the drone has. Automatically it identifies. This is the percentage of the drone. That is how much battery you are left with and how much you can use. And this is the 92% of the communication, and this is the number of satellites. So when you are using GPS, you need satellites to accurately position the GPS point. So you have 15 GPS satellites available for the communication with the drone. Okay, next is this is the amount of space you have in the memory card so that you can capture the data. This is the initial speed. This is the altitude at which the drone is currently stationed. And obviously, there are two modes when you plan a mission. One is mean sea level mode, and this 30 meter is basically right now is in the mean sea level mode. Okay, there is another mode called as ground level, which is like when you are following a terrain, like in a hilly region or a mountain region, you will use this other mode. So based on it, it follows the terrain, not the mean sea level. Now that so this grid can be automatically adjusted based on your requirement. And here, this is where if you click the start button, either you can start the mission immediately, and also once you start mission, there will be a pause button that you can use to manually control the drone once if something goes wrong with the mission. And here you can see there is a timeline given here. Right now, if I plan that mission in that particular grid model, I am having 5 minutes, 13 seconds of mission to fly. And it is covering 53 meters into 112 meters as a rectangle. So that is the area that I am trying to cover. So next is, give me a second. Now that the mission is planned, I am uploading the data into the drone automatically, and then it checks, it performs a checklist. So it checks all the parameters of the drone, the mission, the altitude and everything, and then goes forward with the mission. So it checks everything, and then next, just goes to the next mission, and then automatically see. Now the drone, you can see on this part of the screen that it is a live feed on the screen. Okay, so now the drone takes off once you upload the data and click go, click the start button. See, then a pause is here. Okay, once you click the start button, automatically the drone takes off. The live feed, you can see the live feed in the camera. So the drone is going to the first point of the mission and then starts gathering the data. So you can see the live feed here. You don't have to record. I mean, we'll provide you this. So now, and then once this is very interesting. Yeah, so here the drone will not collect any data because it is transitioning between two parallel lines. And then it starts. So that is then once the mission is over, the drone is returning to the home point position. And now the altitude is 30 meters. Now it will descend. This altitude is basically set based on the obstacle, and also suppose you are in a farmer's field and there are trees. Make sure that your altitude is above the maximum obstacle, and then you plan the mission always. And then you come back. So now it is descending. So the battery is 76%. So it has consumed certain amount of battery and it is coming back to its position. So this is how it descends. and lands. This is the end of the mission. Now you can break the connection with the controller, and then you can collect the data. Similarly, because now the DJI is here, here synchronizing, don't turn off the drone. So basically, it is communicating the mission is over with the controller. That's it. So now that we are not allowed to use DJI drones anymore, there are PX4 based. So this is a firmware which can be used like Linux versus Windows. Like that difference is there. So PX4 based many drones we can build. So this drone is based on PX4 only. So we can integrate any sensor into that, and based on that, so and also we can use Android applications for this. Here also we have the similar thing like how we had in P4D capture. Same thing. So here this is the number of satellites we have available. This is the fly mode. This is the signal with the controller and the drone percentage of signal, and this is the drone. Battery capacity that you have. This is what is the attitude meter that shows you the pitch and mode. This is the compass that shows you the off. So before doing anything, I just want to discuss here. So this is so here if you can see, yeah, this is the triangle here. So the drone was placed at the same position, and the triangle direction, the head of the triangle is basically telling you the direction the drone is facing. And from with that point, you plan the mission again. So here again, this is the speed, initial altitude. Sorry, this is the altitude at the initial position, and then this is the speed at which it is going forward. This is the other altitude of the sensor when it is rotating and everything. So this option tells you the time flight has started and how much time it has spent. So this is the distance. So this is the distance, frontal distance, and this is the speed at which it is traveling. So now we use this option to plan. So this is a Q-ground control application in Android. So you can use this application in any Android phone. Connect it with the drone using the Bluetooth, and then you can plan the mission. So this is how you plan the mission. The next is yep. Okay. Yeah. Once you launch the plan mission, so you have all the options here. Fly. Here, automatic one good thing about this application is because we have an PS4 based drone, it automatically updates home point. You don't have to update the home point like you did in PJ Go 4. Okay, you can do this automatically does, and here you are setting the altitude at 30 meters again. We are setting the altitude related to the launch, as in from where you are launching, from that 30 meters. So it is taking your launch point as a base, and then. Yeah. So yeah, you're updating the takeoff point also here. The minute see here, you can see the related to launch, all that forward. This is Arduino Pilot software. So you're updating the takeoff point first. You're putting the takeoff point from that because it is taking 30 meters. That is very important here. So you're using survey option here from the like you have the survey option in basic. So this is again a polygon we are using, and all these settings here. The survey option, the mission option, basically it tells you the grid points, these parameters are used to plan the mission, the waypoint, the direction of the flight and everything. So here the overlap, so 70% overlap is conventional. So we use the 70% overlap, side overlap, and 70% frontal overlaps. Okay, so every image taken by a drone will have 70% overlap to the preceding and succeeding image. Okay, 70% overlap. So that is the option here. So again, the altitude is 30 meters. So this is the GSD. At 30 meters, we are getting GSD as 2 centimeters per pixel. So this is the resolution of the pixel here using Mika. We use the multispectral sensor on this sensor. So for that, and then yeah, I think I will show this. We don't have time for that. Yeah, and then we set the this lines width using this degree here. This is what you can modify, arrange number of lines, and then see right now it is showing us with this polygon we have distance. We are covering total distance of 1737 meters. Time will be 5 minutes, say 57 seconds, and this is the altitude. Defined altitude. All that is already defined. So based on this grid, this is how you plan the mission. This is the time drone will take to complete the mission. Yep. That is set. Yeah. And one more thing I want to discuss here is the difference between DJ and the PX4 is PX4 gives you multiple options for safety. In a better option, better options than DJI for DJI drones. Here you can apply a fence, that you see the circular fence here, or you can also apply a polygon fence. Basically, what does it do is it provides a barricade to the sensor, drone, so that it will not cross that boundary. It will never cross that boundary. Even the mission, say suppose GPS is something happened to any part of the drone, it doesn't cross that fence, and it will come down to the home point immediately. So that is the fence, and it is important that you do this. So this is an extra feature that PX4 based firmware provides you. That's why it is better in some cases. So yeah, so we updated the fence, and then again do a checkup. All they do the checkup of the altitude and the obstacles and everything, and then launch. Yeah. Yeah, so now we are uploading the mission into the sensor, drone, and then we just yeah. So now you see the attitude meter is showing you the pitch and roll here, and then it is showing the takeoff, and here you can see the altitude, the current altitude the drone is, and now you will see the distance covered and the speed of the drone that is currently in the mission. So it is going to the start point, and then it will start the mission. Here also you have pause option here, so you can immediately pause the mission and take the manual control of the drone and get back into the safety. So after completing the mission, the last point, it will again come back to the home point. So it is returning this is the drone position right now. Okay. Yeah. So after returns, it descends to the home point, and we will discuss this after we come back. Okay. Okay. After we come back, we'll discuss the drone data and everything. Thanks. Hey.
We are going to the field, so hold on for 10 minutes to.
Yeah. Okay.
Like,
people in the Zoom, please follow us, and we'll be live again in 10 minutes because we are traveling to the field to cover the mission to show them how to plan a mission and everything. So we will be live again in 10 minutes. Please be with us. Ground में
Hello. Hello.
रिकॉर्ड तो हो ही रहा है कैमरा में।
है ना? नहीं वो कर दिया मैंने, यही आ रहा है।
अपना वीडियो ऑन कर दो, अपना वीडियो ऑन करो, अपना वीडियो ऑन करो।
मेरा वीडियो ऑन करना मैं दिख रहा हूँ।
What altitude you are taking?
स्क्रीन शेयर कर, वीडियो प्रॉपर वीडियो बनाओ उसके।
मेरा उसमें से आ रहा है किसी और का वीडियो। मेरा वीडियो
वीजा है।
At the time required for the mission. It is your duty to make it that it is your duty to understand if the time limit. So Phantom flies for 20 minutes only. Okay, so it is your duty to plan the mission.
This is the live feed.
In such a way that the mission entire covers 15 minutes only.
Drone is coming and capturing one image.
And also the restrictions. So the restrictions when you are planning drone mission are three things. One is battery. Okay, that is the first thing. Second is the obstacle. You have to make sure that the drone is not facing any obstacle. Remote connectivity also. You have to make sure all of these are correct. Then only you have to put the mission plan. So you can now.
So here you can see the path of the drone. These are all scan lines, and the red side is the front of the drone, which is coming now towards us. So that is why it is facing to the road, and it is capturing images. You can see those tiny camera type signs. This is images taken, and this is the live feed from the drone. Now the camera is downward, facing towards the field. So you can see the entire field. Drone is moving and taking one image. Again moving, it is taking one image. So, and if you come here, you can see the entire how much area covered again, all those things. And now you can see speed was 1.8 meter per second initially, which was 0, and altitude is 20 meter. This is the pause button. If I press that, the aircraft will be stopped and I will have it on my sticks.
Go have
your tea. Get your tea. The drone is flying anyways. जाइए
Yeah.
वो आएगा. It will come. We go eat, drink tea.
Audio Tarun.
Sir, hello.
Around 2 lakh.
वो बोल रहा है. मैं उसको ही बोला. लो.
एग्रीकल्चर फिजिक्स करके
The participant see the live from agriculture physics Zoom में.
बड़े ड्रोन में अभी प्राइसिंग हम अराउंड 2 लाख के आसपास ही होगा ड्रोन का प्राइस, बट ये हमारा यहाँ मेड है तो हम ये मार्केट में अवेलेबल नहीं, ऐसा नहीं है. जैसे ये एरिया कवर करता है तो इसके बीच जो दोनों रो के बीच हमें सेट करना पड़ता है. यहाँ पे आप ओवरलैप के हिसाब से सेट कर सकते हैं, या फिर आप यहाँ पे और अपने को मैनुअल लेकर डालना है आपको कि मुझे 2 मीटर चाहिए, 5 मीटर चाहिए, तो आप वैसे भी डाल सकते हैं.
Yes. Sir. थोड़ा नीचे मैं करता हूँ.
इस पॉकेट में वोल्टेज टेस्टर है.
बेल्ट पे ना. बेल्ट पे ना. ऊपर पे काटा.
तो ये माइक में इधर लगा दे सकता है. इसमें लगा पीछे इसमें लगा ये अंदर से. इसको ऑफ करने का क्या बटन है कि जब मैं चाहूँ ऑफ कर सकता हूँ, तो वो अंदर से होगा. कोई नहीं, अभी तो दिखाना बटन.
बढ़िया बढ़िया.
ये वाला होल्ड किया ऑफ है ना, होल्ड प्रेशन होल्ड.
दिक्कत है क्या? ठंडी हवा जा रही है ना. कहाँ जाएगा ठंडी हवा? कहाँ जाएगा? नहीं जाएगा. कहाँ जाने दे. हाँ बस अब रहे. अभी थोड़ा
जो ये कैप्चर टाइम है इसको हम कंट्रोल कर पाते हैं. जैसे मुझे यहाँ पे कुछ
हम ओवरलैप अगर चेंज करते हैं तो वो टाइम भी चेंज हो जाएगा.
अच्छा, ओवरलैप अगर हम चेंज.
हाँ बिल्कुल.
तो यार हम उधर बाहर हम देखे भी नहीं है ना. तो यहाँ हम देख भाई ना कि हम यहाँ क्लास चल रही है तो हम बाहर अंदर ही बैठे हैं. हमें तो 50 दिए.
The last line?
Yes, it is the last.
Okay. So you will hand over the controller to me when it come to the end point.
Yes, yes.
Okay.
Yes. रुको ना भाई, पकड़ा हूँ.
Is there anybody? इसको उसके अंदर रख देना, वीआईपी बैग के अंदर. ठीक हो, रख दो. वीआईपी बैग में रख दो. So थोड़ा सा पीछे हट जाइए, लैंड करेगा. Everybody just a little side. So as we can see,
please observe from there.
The drone is now at the end point of the mission, so it will come back home automatically. So now you can see it is coming back home. First it increases its altitude to 30 meter. As it is set as return to home altitude, then it has come back to its home point that we updated here. Okay, and now you can see the red lights facing this side. That means now face is that side. So it will make a turn automatically. See, it is turning automatically. So now the face is towards the field as it was at the initial position. So now it is descending. So now you can control it manually a little just to make it land properly.
left, थोड़ा left, नीचे, थोड़ा left. So that's a safe landing. So now the drone is updating its path into the controller, the device, and then we can exit the switch of the drone.
So first power off the drone, then power off the remote controller. Disconnect the tablet from here. Okay. वो रख लो आप. Propellers लगाओ. Propellers लगा. विशाल कहाँ है? Up to 17 minutes. विशाल propellers लगाओ.
एक मिनट हो जाओ. किधर रखा हुआ आपने?
माइक पीछे रखा है मेरा.
इसको ये वाला हाँ बताएं. And also they want to
लगाओ.
वो बोलेंगे अब छोड़ो बोलो वो वाला क्या होगा. You need to tell, no? Explain that.
Okay. So as you can see, we are now making ready the aircraft. The propellers are fixed on the motors. So it's a hexacopter. Previously, the drone we flown, it was a quad. So it has 4 propellers. It has 6 independent rotors. So it can lift more weight and can fly for more time with a bigger capacity battery if we use. So here you can see a multispectral sensor is under the aircraft. So we will do multispectral imaging now, and we will plan the mission as we flown previously. So after some time we will fly. So first we have to check that all propellers are tied properly.
One of the components is the battery.
Yeah.
ESC.
Yeah.
ESC controls your motor. Motor controls your propeller. That gives you thrust and goes up. And what happens when it goes up, when you to go front and back, all these motors, this propeller speed keeps on changing.
Yeah.
Accordingly, it will go left, right, or that's what the whole basic principle.
Yes. So give me the remote. Yeah. So heading change कर दो आगे. Hold the remote. Face उस तरफ करना. So now we are made the heading towards the field because the drone will take off from here and it will go straight towards the field. So if we do the heading towards this side, it has to rotate in the air. So we don't want that, and for safety reason again, this arrow of the GPS is the heading. So we are making it towards the field. So now
the red color, you see, that is your heading point, and this is the GPS and compass here. Here 3 GPS, and the sensor is down there.
सबको
So it's not synchronized with that. So it is called DLS. That is for light calibration automatic mode, and also there is a GPS inside. So two things are there: automatic light optimization, and also there is a sensor down. Where is the reference panel?
It is on the that side. विशाल कनेक्टेड टू द मिकासेंस अभी वाईफाई रखो बैटरी तो हाँ मैं लगा देता हूँ
Optimization. So what is the light condition? You take first the image on this, then based on this, you will go for optimization. Okay? So before takeoff and after landing, you should do, because in between there will be light changes, right? So this is what the reference panel, and then the procedure written there how to do it. And this is what the and the value is what you want to give. While processing, this value is required.
मैं लगाता हूँ रुको
करो.
Okay, so as you can see, the previous drone has a power button, but for here, you can see there are two connectors. One is coming from battery, which is called the XT90 female connector, and this is a male connector which is going towards the drone. So if we connect these connectors, the drone will be powered on. So I am connecting it. As you can see, light on the GPS module, motors are beeping.
Be careful.
Yes, sir.
Please move back. Simply if you are one out of order. You don't have insurance.
मेमोरी चेक करते रहना कि अगर भर रहा है. So now I am connecting it to the GCS or ground control station. The remote controller itself has two type of feature. One is the RC link, that is the radio control. It communicates to the drone on 2.4 gigahertz, and by those six there are 6 channels. So to these 6 channels, it controls the pitch, roll, yaw, throttle, and all the motions like mode, changing the modes and all. And after that, there is a module inside the remote controller that is called telemetry and ground station. It is connected to the mobile phone via Wi-Fi. So we can observe all the flight parameters here inside the mobile and plan the mission from here. So right now I am connecting the GCS to the remote controller.
Later flight mode.
So somebody is doing video recording, right? Rahul? Video recording will be.
So now it is connected to the GCS or ground control station. So here everything can be shown. This is the mode switch. So if I
Free arm. Meter temp low 36.8
so
left.
if I change the switch, like if I press the switch upward,
Land flight mode.
there is a mode called landing. It will land automatically. In the middle position, it is GPS mode. So it will fly and hover stably with the help of the GPS. In the downward position, it is called altitude hold mode. That means drone will maintain its altitude, but rest of the things the pilot has to do manually, the controlling. So I am in loiter mode now and check the microsense
Free
camera.
arm. Meter temp low 40.0 less than 40.
192.168.
Okay. The sensor it has its own software. So you have to connect that to again Wi-Fi Bluetooth connection, and there is a given IP address. You can click, then automatically the sensor is connected to your mobile. So you don't need to download any.
Free arm. Hardware safety switch.
In the class, all the details will be given. Most important is when capturing an image, what is the overlapping you require? Because you need to put images together. So 70 by 70, vertical and horizontal overlapping you require. Whether you want to capture the same voice or the streaming, so you will be doing the streaming to the and based on that, data capture is going to everything will be shared. There are a lot of options available here, and there is a memory card also in the image.
Free arm. Hardware safety switch.
Okay. So right now I am planning the mission on the GCS. So it was explained inside the auditorium. First, I have done a mission start altitude, that will be the initial waypoint altitude. That means the drone will go to the first waypoint from where it will start the survey, and altitude of that is 20 meter. I am setting. Okay. Next, I am coming to the takeoff altitude. So suppose I take off manually, then I have to match that altitude before starting the mission. And if I perform a auto takeoff, then the drone will climb to 20 meter height. Okay. Then I am coming to survey. In a survey, there are multiple parameters. Suppose overlap. We are changing. Conventionally, we go with 70% overlap. So we are setting overlap front and side both 70%. Our altitude is 20 meter. Next is the angle, or which is called course angle. That means we want the drone to fly like this or like this. So we can change this accordingly. But the best thing is to preserve the battery. For more endurance, we have to decrease the number of turns in the mission. So uh, we have planned mission accordingly, and our entire mission timing is 6 minutes.
Because since job, you tell me, then they will connect.
Okay.
Since power is
Okay.
Once you're ready, you tell.
Okay.
Pre-arm. Hardware safety
At the
switch.
last point, I have to give a return point. That means the drone will come back to the home point and land automatically. So I am pressing the return button. So now everything is set. Mission start. Initial waypoint altitude is 20 meter. Our hover speed is 5 meter per second. And after that, takeoff altitude is 20 meter. Survey altitude is 20 meter. And at last, the return to launch will be performed. Okay. So we are checking these things 2-3 times.
Pre-arm. Hardware
Mission
safety
start.
switch.
Connect कर दो.
Connect.
Mission start. Mission open altitude. Mission open altitude. Mission start. Mission open altitude. Mission start. हाँ. Mission open altitude 20 meter.
Pre-arm. Hardware safety switch.
Are you able to see those coils, copper coils?
So
There's a magnet ringing all around.
yes,
So once
देख लो.
it is on, it will stop. Like create a force. The amount of current so to different.
Pre-arm. Hardware safety switch.
That's what the purpose is. Based on that, pressure will be.
No sir. आप नेट ऑफ कर दो.
कभी कभी कभी
नेट ऑफ कर दिया. रेडिट से कनेक्ट करो.
Okay, okay.
हो गया ना. अब जाओ वाईफाई पे. आईपी डालो.
फिर से करना.
आईपी तो सेम है 192.168.254.
अभी चलाया.
उसी को फिर से क्लिक करके फिर से वही करो. सारा बंद कर देना है बैकग्राउंड.
हाँ खुल गया.
अब खुलने दो एक मिनट.
नहीं
मैं कर रहा हूँ.
कनेक्टेड नहीं है अभी. 0 वाला ना.
मेमोरी खाली है पूरा. 29 GB खाली है. कुछ डेटा नहीं आ रहा है. कनेक्ट नहीं हो.
इसको दोबारा लगाओ.
यूएसबी केबल को डिस्कनेक्ट करके दोबारा कनेक्ट करो.
डाटा नहीं लेना.
हाँ
तो
छोड़ दो.
कैसा है चावल?
लाइट ऊपर आ ही नहीं रहा है. ब्लिंक हो ही नहीं रहा है उसमें. देखो
चावल तो वही 13 रुपए में लेते हैं.
डीएलएस में लाइट
दो नाम था. कुछ नहीं होगा. तू कर. रिमोट मुझे दे दो. करो.
ना तो होते हम ना लेते हैं.
जियो में नहीं कनेक्ट करो. रेड डेट्स में कनेक्ट करो.
अब आया. ठीक है.
ना अभी देखो.
हाय ने बेच देंगे बिक गया.
आ गया. हाँ अब आईपी में जाओ.
तो चाचा है ना वो होती तो आप बात कर लेते.
कोई दिक्कत नहीं है.
आ गया ना.
ठीक है.
स्टार्ट कर दो.
स्टार्ट करो. तरुण मुझे रिमोट दो. जीसीएस तुम रुको अभी अपलोड नहीं हुआ.
करेगा फटाफट. नहीं रुकेगा. वो भी ऑप्शन है. रुक के करेगा. ज़्यादा टाइम लगेगा.
बैटरी को हाँ लाइक करूंगा. So now I am uploading the mission to the drone. There is a button which is called upload required. So if I press it, the mission is uploading. to the drone now via this antennas. Okay. So kindly move back. It's a big aircraft.
This drone produces more thrust, so please kindly move back. Be in a safety.
You should be.
तरुण मेरे बाजू में रहना, ठीक है? GCS दिखाते रहना. Okay. So now I am going to the fly view, and everything is set. So I am ready to take off now. Okay. So I'm performing a fully auto takeoff. You can see here everything is set. Everybody is there. Okay. So I am taking off the aircraft now. Yeah. रुक जाओ.
सर होने दो, विकास से प्रॉब्लम नहीं है. ठीक है.
So I'm taking off now.
Guided flight mode. Arm. Yeah, RC4 is not neutral. Arm. Yeah, RC4 is not neutral. Arm. Yeah, RC4 is not neutral.
Remote पकड़ो. Just hold it.
मैं दबो.
नहीं रुको, मैं हट.
Arm. Yeah, RC4 is not neutral.
वही प्रॉब्लम आ रहा है इससे कल वाला.
Arm.
Taking off. Okay. So you can see it's a fully autonomous takeoff. So after takeoff, it will go to some height, and now I am shifting to a fully auto mode. Now it is climbing. For 20 meters.
So the altitude.
So now it has reached towards the 20-meter altitude. It is going to the start points, which is almost near to that building. And
first point पर जा रहा है.
okay, yeah. So now it is on the almost reached on the first point. Okay. So here everything can be shown inside the GCS. That height, climb speed, timing, etc. All the parameters can be shown, and you can see the drone flying there. Here you can see the entire telemetry information is coming inside the
No problem. You bright maximum.
नीचे करिए फोन को नीचे यहीं पर रखना जी. हाँ बोलिए आप. Okay, here you can see every parameters are inside the GCS. Like first is your attitude indicator that is showing all the parameters here. How much the tilt angle in the pitch axis, how much the tilt angle in the roll axis while it is moving in the air, and it is the compass or called heading indicator. It is showing that what is the angle it is facing now from the electronic compass inside the drone. And here it is the altitude 20 meter. It is the climb speed, which is 0 now because it is fixed on same height. It is the time. It is the travel distance. Next is the speed, and after that it is how much distance away from that remote controller, and all rest of the parameters you can see here. So now the drone is in autonomous mode. It is flying. 14 satellites are connected to there, and our battery is 95%. You can see here, and our voltage can be seen, that is 20.8 volt.
One more thing, you can now see the grid points, right? So this is the grid in which the drone is covering. So that is very important. And also, in the left panel, you can see the pause button, which you can pause if you want to stop the mission. and then take the manual control of the drone. And here the most important thing is, when you are planning a mission, you need to always observe the remaining battery. Okay, it comes in two forms, that is in percentage and volts. So always make sure that the battery maximum percentage while taking off is 25 volts. And then when and what is the minimum?
Minimum percentage to
Minimum,
land is 30%.
30%. And voltage?
Voltage should be 20 volt for this drone.
And maximum?
Maximum is 25.2 volt.
2 volts. So that is how you have to plan a mission, and then make sure that you always observe the remaining battery percentage when the mission is going on. Okay. So right now the voltage is remaining battery percentage is 93%.
रहने दो.
हाँ सर, अभी आप
हाँ अभी आप ड्रोन को दिखाओ. जीसीएस मुझे
see if the drone voltage drops. मैं उधर आता हूँ. If the voltage drops beyond 21, the drone will. So you have to make sure that the battery is between that range only. That is the optimum. No, not like that. 19 volt is what we keep, but for safety purpose, 20 volt, 21 volt.
The voltage level is different for different drones and battery setups.
Yes.
So it's a 6S setup. That is why it's around 20 volt or 21 volt.
So whether we have to manually bring it back or it automatically aborts the experiment and returns when the battery percentage.
It is automatically aborts the experiment
Yes.
and performs a return to home.
That is a safety measure inbuilt.
So even though if we won't check the battery status, we also know.
Yes, we also check.
No, it's important that you keep a note.
Yeah.
मैं पकड़ता हूँ.
बैटरी देखते रहना. बैटरी है आराम से हो जाएगा. 21 वोल्ट से आराम से होगा.
And also we have two types of turn. One is standing and rotating, and then there is curve rotate. So if you want to preserve the battery, you have to put it in this mode where it stops, then goes like that. If you make it like that, it takes more energy. So be careful about that.
How much area can it cover?
It depends. Different at different altitudes, different area. So it also depends upon. Say, suppose I want this entire agriculture field till that point, it will be difficult at this altitude. So if I go to 60 meters, probably I can. Maximum time it flies is like 20 minutes. In the for this drone, it is only 15 minutes, I guess. This was out of order, na?
Yes. Yesterday it was out of order. So it is repaired overnight.
Right now.
So now you can GSD. It will be around. So we have to check with the camera settings because it's entire for the drone. So we have to check with the camera
Mostly
settings.
for Mika sense, it will be around 1.
Hold it. Last point. Now you can land आ रहा है. भाई यहीं आएगा ना? Auto आएगा. Everybody just give me a side because the drone will come back home now. So back. Everybody side. Side. Okay. So now you can see it has come to the home point, and now it will start descending. It is descending automatically. I have only control over the pitch and roll. Okay. So I will make just a little. It will land automatically. I am doing nothing on the remote controller, and it will disarm. Yeah, take. दो, पकड़ो. हाँ पावर ऑफ, पावर ऑफ।
जॉन तो नहीं है माइक।
हाँ पता नहीं, पता नहीं मुझे भी। अरे यार एक बटन ऐसे प्रेस,
मंदिर में ज्ञान सिर्फ इतना दिया फिर जरा पता
ऐसे मत पकड़ो, हो जाएगा, आप छोड़ दो, छोड़ दो। दिस इज मेड इन IRI।
स्ट्रक्चर का डिफरेंस है। डिजाइन बस हमें यहाँ जैसे इतना सारा फ्लाइट करते हैं तो विंड स्पीड वगैरह सबको देखते हुए ये ठीक है, तो सब कुछ सेफ है।
कौन सी कंपनी के बारे में इंडियन कंपनी
Meter 10 flow, 23.6 is less than 40.
मैं रुक जाता हूँ, कौन सा होगा?
यही तो होगा।
हाँ मैं रुक रहा हूँ ना। लेंस कैप उसकी जरूरत भी नहीं पड़ेगी, मैं निकाल देता हूँ, रुक।
Meter 10 flow, 27.3 is less than 40.
फास्ट बूट बटन लगा दिया,
तो क्या होता है?
बाद में बताऊंगा।
दब गया,
मैं पता था तब क्या था।
वो भी बैटरी से दब गया होगा।
क्या?
अच्छा इसको मैंने से पहले
मैं कनेक्ट
नहीं वो ऐसे ऐसे दबा, उसको रखने से दबा ना।
Free arm, meter 10 flow, 30.5 is less than 40.
अभी तो चल रहा है ना, जोड़ लगे
वो जुड़ा है, कैमरा ऑन है, कैमरा ऑन है।
उसको मत कर।
लाइट आ रही है भाई उसमें, वो नहीं आना कनेक्ट।
ये आया तो मतलब चल रहा है सर, है ना?
हाँ हाँ बिल्कुल सही आनी जाना। सुनो सुनो उसके लिए
थोड़ा लेट आता है ब्लूटूथ से और
वो ब्लूटूथ वहाँ ब्लूटूथ इसको प्रेस करो।
Free arm, meter 10 flow, 33.7 is less than 40.
ब्लूटूथ ऑन है, ऑन हो जाएगा उस पर ग्रीन होगा।
Reuters light mode.
कनेक्ट है, इतना करना है बस। सर्च कर रहा है, आप रुको, सर्च करेगा, 1 मिनट लगेगा।
ओके
Free arm, high GPS stop.
तुम्हारे में राहुल कभी कभी किसी किसी
नहीं इसमें
चल
इस पे करो।
अस्सलाम इसको अपने को बंद करो, अपना क्लोज करो।
इन दोनों को ही चलाया।
सन्नी मैडम को ले आओ मोबाइल पे चले।
नहीं हो जाएगा, सेल वास हो जाएगा।
सच
HDOP का प्रॉब्लम आ रहा है, HDOP का प्रॉब्लम आ रहा है।
बोलो ना, लो बैठ करो, जबरदस्ती नहीं।
फर्स्ट डिस्कनेक्ट
सर एक मिनट
सर को बोला
डिस्कनेक्ट करो, फिर से लगाओ।
हाँ सर को बोला
एक बार डिस्कनेक्ट करो, फिर से लगाओ।
बुला लो साहु सर को बुलाओ ना।
वो पहले इधर आ रहे थे। अब रुक जाओ इसमें, इसको भी करना।
3 arm, high GPS stop.
Okay. कुछ बोल रहे? हाँ हो गया।
So we have to wait for 5 minutes because HDOP high.
No issue. Don't worry.
Okay.
Till now, what is HDOP?
Yes, sir.
3 arm, high GPS stop.
This is a. What is this? Anybody? This is the RC remote controller, but it has everything. This is a Hairlink model. Everything you can see. You don't need another system. Everything. So the issue is that
Communication lost.
is not there. It is having SDOP is very high.
That means
Dimension of precision.
yes.
You know, GPS should be scattered all around. GPS satellites. There are 24 satellites. If they are clustered around like this, or they are like this is wrong. Because the model, what happens, accuracy, how it decides, you know what the principle of GPS? No. There are suppose 3 GPS. Each GPS has its own locations value, X, Y. X1, Y1, X2, Y2, X3, Y3. So like this, you have GPS. So you have a location unknown. Okay. So what you will, it calculates where the GPS is right now, based on that fraction of second. So, and what is the distance? The distance measured in terms of light, faster. The light speed is, you know, 3 into 10 to the 8 meter per second. And so the distance is calculated by the formula a square plus b square root over. So the distance, that is x1 minus x2, that is the distance square plus y1 minus y2 square, like this. So you will get a 1 GPS, you get equation like this. So you have 4 GPS, so 4 equations. Then you can solve x1, y1, z1. And fourth one is because you have an offset error, so that has to be corrected. So that 4 GPS minimum you should have. If they are clustered all around closely like this, then what will happen? The x1, y1, z1, all those x1, x2, x3, their variation is not much. Right? Suppose you do water sampling or soil sampling, you do only here and go back. You say the whole iris soil sample is this. This is wrong, no? You have not taken care of the variability. So that is wrong. Same also here. The location variations is not much if it is clustered around. So when you saw all the GPS which is connected right now, they are almost clustered. They should be far apart. So that's what dilution of precision is called. So if it is far apart, then accuracy will be much better. So there is an option. It will tell you if it is clustered like this, then you give a signal. You won't take any observations. And flying is going to be dangerous because you don't have a proper signal and accuracy is not good. So that is the reason. So now you see.
Wait, I'm connecting. Wait. Remote to do.
So this is homemade. He made only all this. So there is a thermal camera here. Again, the thermal camera is radiometric in the sense it will give the radiation received. Then you can convert that into temperature. There is a formula for that. Then you can get the data to the.
Oh, correct.
Stabilize flight mode.
No GPS.
3 hours.
Aega.
Meter temp low. 38.3 is less than 40.
इसका content किधर है?
Sir, that side, towards the field.
ये red color इधर रखिए ना.
It is opposite to DJI.
Okay.
वो करें? Yes. Okay, see now you can see the horizontal dilation of precision is 0.8 and it is required it should be less than 1. Okay, so here every parameters can be shown. This is the battery voltage and all. So now I will plan the mission. So after planning I will explain those things. Okay.
Later flight mode.
अरे नहीं हो रहा है
रुक जा बाद में दिखाएंगे.
थोड़ा बात दिखेगा.
If any question you have, we can discuss. Till now. Yes,
यार अभी नहीं हो रहा.
क्या थर्मल का प्रॉब्लम है भाई. डेटा की जरूरत नहीं है मिकासेंस में. हमने डेटा ही नहीं
कनेक्ट तो कर सकते हैं. नहीं भी होगा तो कोई दिक्कत नहीं है.
लेकिन दिक्कत नहीं है.
On the mobile itself, you have a app. From there, you can connect.
नहीं हो रहा.
And this is GPS for that. Thermal.
अरे इतनी दूर भी तो यहाँ भी तो कनेक्ट करें.
लगा है वो लगा है.
थर्मल
की जरूरत नहीं है.
सारे बनते हैं.
Mission start. Mission start.
छोड़ो आगे छोड़ो.
Mission 20 meter per second.
कहाँ है? The light is blue. Light एक बार प्रेस करना पड़ेगा. ब्लू लाइट आ रही है. साउंड तो आया ना.
ब्लू आ रहा है ना. जीपीएस है तब कैमरा में जीपीएस है.
ब्लू ग्रीन नहीं
कनेक्ट कर लो.
ठीक है.
ये डोंट टच.
छोड़ ग्रीन बोला है. हो गया. आगे करो कनेक्ट. टाइम ले रहा है.
पास ले.
डिस्कनेक्ट. हाँ हो रहा है. करना नहीं चाहिए.
So now they are connecting the camera with that mobile phone via Bluetooth. So it is taking all the camera data and all, and now he will start capture. You start.
Auto capture.
Yeah. So now capture is started. So after starting the capture, and now I am taking off the drone. So it is in fully in GPS mode. So now I am arming the drone. Everybody a little. So I am taking off. Vishal, a little. Everybody. So now I am at 20 meter height, almost. Okay. at 20 meters. So I am shifting it to auto mode. Yeah. Yes, sir. So now it is going to the first point. सर के पास मैं यहीं लैंड करूँ, ऑडियो आ जाएगी सर के पास आ जाएगी।
Under flight mode.
आऊँगा आऊँगा।
Disarmed.
So this is the in-house drone made by IRI. This is the capability. If it can be developed, then we can make multiple drones here, and it's all because of our team, and all because of our team that sir, Sahu sir, Rajiv sir, and all gave us this opportunity to make the drone. And my friends Tarun, Rahul bhaiya, Manish sir, all helped me a lot to stay with me, to help me, give me this, give me that, like this type of things, all those things, designing some parts and all. So this is all the demo. Thank you so much, sir.
So any question you have? Anybody? Yeah, one. So while doing mission planning, you have to be very careful, of course, because the time direction doesn't have any issue. What is the field length and breadth? So like, suppose this is your field and length is from here to there, then the images should be done like this, not like this. Because when taking turn, you see how many times turn people take. Automatically the battery consumption is there. Always you have to be careful with the battery time. Very critical for you. So if it goes like this, hardly 2-3 turns it will take. So it will save. That is one thing. Second is, there is an option in the drone itself, 20%, 30%. That's what level of battery. Once it reaches to below 30%, automatically it will come back. It won't capture the data. Automatically it will come back for the safer side. So that's what many times we give. And suppose you are in the like your field requires 19 minutes and you have only 20 minutes mission planning. So it may so happen battery consumption is goes up, because when you put it on, do calibrations, all it takes battery. Right? So you never know. So then what happens? Mission starts like, but you might have seen it has gone to that corner, started mission. That is the starting point. It took the image. Again might have gone to that side and came back. That's no problem. That's not live. इसको बंद करें अभी रहने दो कुछ अगर हो सकता है कोई ऐसा कर main point goes back so that if something goes wrong it comes back some beauty here coming there is coming take the cable for the battery again when coming more battery than D type
तो नहीं बोल रहे हैं माइक तो लगा है बोलोगे नहीं बस फोटो लेना है
You can keep 30 meters while your data acquisition. While coming to RTH, return to home, that should be also 30 meters. So because there is no obstacle, but suppose I fly that side, then there is a tree and pole, all those things. Safer side, you can keep 50 meters. So it goes off 50, flies, then come back here and lands. While taking off and landing, it goes with the bigger thrust, so battery is consumed there. So one has to be very careful for all those purposes to optimize The mission planning is such a that starting point and end point should be close by you, so that battery is saved. Okay. Anything?
Sunlight direction, sunlight. So
Anyway, it is going to capture the data because in the top, and you are taking not a directional capturing you are doing.
in a proximal sensing.
So that matter, but it captures data like this. But it has an effect with respect to shadow. Like you have bigger tree like mango, the sugar cane or anything, the shadow effect will be there. So one has to be very careful based on sun, which side you should take so that shadow effect is not there. Okay, maybe there is a big tree here, like there is a big tree, there will be a shadow effect on the field. Anyway, one has to see that how we can optimize that. Any? Yes.
The height of flight is decided. It's like not here. We're deciding 20 meters.
Like the area, what the area you want to cover, what is the battery endurance time? Like you have given only 10 minutes you have, and the area is this much, and you will see optimize accordingly. Within that 10 minutes, I should be able to fly, get the area covered. And suppose you are not able to do that in 10 minutes time, and you want a resolution of something around 1 centimeter, then height should be around 15 meter. For example, that calculations, but time is now 15 minutes. Then you can't do that. Then either you can do one thing is 7.5, 7.5, 2 heights you can fly, or you can go to bigger height so that area coverage is bigger, so that it covers.
For spraying insects, said how much?
We are not talking right now, but insects mostly 2 meter to 3 meter height. Again, there are a lot of issues with respect to the thrust. I'll show you some of the photographs recently what we have done. Because some of the plants may get damaged because of the heavy thrust what you get, and so but it has to be close by 2 to 3 meter, not more than that, to spray. Otherwise you will have a drift. Like now wind speed is maybe more than 20 kilometer per hour. So drifting will be there. Where you are spraying, it will be going some other directions.
Wind direction will go also important in sectors.
Yes, and here also wind. Suppose it's windy, you can't fly. You should not fly rather. So, and here these two drones, they don't have the gimbal. So he's going to do videography. It's a smaller drone. Pratim, you are doing videography? Yeah. So these two drones, they don't have a gimbal. Gimbal is attitude, roll, yeah, pitch. And you can make also that movement. Like in a particular directions you want to take the photography, that can be done. There is a gimbal there. And you will see in the lab, you have a hyperspectral camera, there's a bigger gimbal. Okay, Ronin gimbal from the DJI we have taken. Very expensive. That again, something weighs around 1.8 to 2 kg. So you can direct as you like. So for a different purpose you can do. Like he was talking about the light condition. So this course doesn't cover in this class. So we do BRDF measurements using some ground facilities. Same also you can do by drone. That's what you can do, different angles you can take the data. So this drone has around 45 minutes endurance time, and it can go up to around 1 kg payload, and it costed us how much, Pratim? Around 2 lakh, 1.8, 2 lakh. And that one, what is the endurance?
That one can fly up to 40 minutes with bigger batteries and smaller payload. And right now with this battery, 15 minutes we can get with Microsoft camera.
And its cost is something around 5 lakh. So see, 2 lakh versus 5 lakh. And this is in-house made. And this is costing something around 1.8. This is long back, 5 years back we purchased this. And you will see a bigger drone again next day. Maybe Monday, Tuesday, we have a whole session on that. And that is a small, which you can go in a greenhouse, anywhere you can capture the image. That is a hotel having a RGB camera. Any question? Everything is understood? Anybody wants to fly? Knows? Anybody who knows flying? Give him. He is flying. You can give the DJI you want. Anything.
सारे लोग एक तरफ आ जाइए तो एक फोटो वहां से ले लेता है.
कम. बट ये लाइट इधर है ना, उधर से लो.
तो हाँ उधर से ले.
Surya, Rajit, all, everyone, थोड़ा लाज हो जाओ, फोटो तो बहुत अच्छा आएगा. सीधे आप आ जाओ अभिषेक, विनोद, कन्या, एवरीवन सीधे हो जाओ. तरुण, यस, पीछे. शालिनी, आरुषि, where they are gone or what? Oh, कहाँ है? Okay. और नीचे ले लो, पीछे ले जाओ. Done.
Capture.
Thank you. So you have captured RGB, you have captured multispectral and also thermal. So afternoon, you will have a clash. How to do those data analysis, and again mission planning, there is again a new software, and you must be using ArcGIS. That is the software which is from ISRI, and ISRI India is a huge corporate company. Many who are working on geospatial science, they must be knowing ISRI. Tomorrow they have user meet here only in the AeroCity. So today he has flown from Calcutta all the way to tell us how to do that in using two softwares called side scan and also drone to map, and also using image processing software, whatever image processing software we have, how we can do drone data analytics. Okay, today afternoon whole session they are going to take out. So I welcome you. Thank you so much. So I'll join you as soon as I finish the meeting and DST. Thank you. Okay. So we'll now break for lunch. Straight you can go to the guest house, have your lunch, come back by 2 o'clock. Okay.
Recently, DGC has approved new institutes for drone pilot licensing. Whether we can expect IRA also as a part of that.
check. Hello, 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 check. Hello, 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 check. एक मिनट. हेलो हेलो हेलो. वो ना बस वहां से पैचिंग केबल ठीक नहीं लगी होगी तब वो
For 2 consecutive sessions on processing of
ये ऑफ कर दो. हाँ.
Today we have Dr. Suryadev Chakrabarty for 2 consecutive sessions on processing of UAV remote sensing data. He has completed his master's from IIRS and PhD degree from NRSC. He has also received Young Scientist Award from KIT Germany and has 40 years of experience in GIS based technology. Currently, he is working as senior analyst in ISRI India. We also have here Ms. Arushi Dubey, Assistant Business Manager, ISRI India, who has provided us with continuous support for software-related queries and trainings. I would like to have the opportunity to mention about Mr. Sandeep Verma, also the manager of solutions at ISRI India, who couldn't join us today, but has helped us with multitude of
Okay. ये चाहिए क्या? Sorry, I'm sorry. It's came?
Yes.
Share screen करना है. Share screen is already there, ना? Share screen तो है. मेरा PPT. Okay, fine. Okay. So, hello. Yeah, fine. Thank you. So, screen share कर दिया? It's coming. Zoom पे. Yeah, yeah. Okay. Okay. You have to select. नहीं select and share. ये वाला. हाँ नहीं यही वाला. ये नहीं करना. ये total screen share करने से क्योंकि मेरे को सॉफ्टवेयर में दिखाना पड़ेगा. ये करेंगे तो सिर्फ PPT आएगा. Yeah. Okay, fine. Yeah. Yeah. Okay. Thank you. Fine. Okay, like this I will do. Full screen only I prepared. This is full screen. In my screen it is coming like that, that's why. ये वाला है क्या? Full view होगा? Not this one. This is for this is full view I think. No, not this one. इसको off कर दो. Off कर दो. Yeah, no, fine. Okay, so we'll start. Yeah. Thank you, everyone, for joining this particular session. So I am Suryadev Chakrabarty from ISRI India. Mostly I am handling the image processing and the training divisions of ESRI. And in today's lecture, which we will going to provide, that is over 2 different parts. Okay, so as you see in the first half of the sessions, what you learned there, that is how to we will capture in the data. Okay, so that is the process you just seen as of now. Now the next things which will come, that is basically the processing and analysis, which we are going to learn from this particular session. See, whenever we are going through drone, so you should know few things which is very important. Okay, like it is not only kind of a data analysis, like you have to know about what particular sensors you are actually flying, what should be the flying height. Okay, so these all things are very important. Maybe you've seen that time when he is operating through some apps, so everything is mentioned like altitude, height, all these informations. So these all informations, if you are experienced in data processing, okay, in satellite data, so satellite also we are doing these all things. Okay, so when we are using these all things, so that is for the calibration purpose. That means when we are starting the data processing, some kind of data calibration purpose, you require those informations. And in case of drone, we have to go through with all those things. Okay, so that's why those calibration informations is also required during a time of data processing. Okay, but now softwares is actually going day by day are very smart. Okay, so earlier this type of data processing, if you know about suppose 5 years, 10 years back, since I'm talking about, so that time usually we are not getting drone data this much in frequent way. So that time the aerial photographs we are having there, and usually we process our aerial photographs. Okay, so the next generations, you can say, the development which we'll get, that is the from the drone. Now we are going to tell you those technology changes, means why I'm telling these things here, because we are going to show you 3 different softwares where we can process these all data sets. Okay, these drone data sets. So one is, I will start with the very start, means from ISRI India, what we are actually providing, that is very fast data product which we are providing, that is ArcGIS Pro. So maybe you heard about ArcGIS Desktop. You may, few people you are already working ArcGIS Desktop. Okay, but ArcGIS Desktop, you can say after some time it will go off, and then ArcGIS Pro will be the future. So now ArcGIS Pro is much more futuristic software where you can do all this type of processing. Okay, that is from the any kind of satellite data processing. That may be a SAR data, that means a LiDAR data. Yes, hyperspectral still not included, but in next version maybe it will also going to include. So with that, we can able to process the stereo photogrammetric things in ArcGIS Pro, and there only we will get 3 options. You know, the stereo photogrammetric we are using over the aerial photographs, over the satellite data, over the drone data also. So ArcGIS Pro also you can able to process all the drone data. So this is the one things which we will, but this is a, in general you can say it's a basic, very basic level, because in our desktop platforms we are working this. So you should have very strong software. You just, I'm telling, whenever you are going to start processing data, so you require a software. So do you know that it is not like that any software I can install in any laptop and which we can process. So you should know minimum things, that is we call as called system requirements. So system requirements you should know. So what is the system requirements of ArcGIS Pro and ArcGIS Desktop? The difference first you understand. So ArcGIS Desktop we required only 4 GB RAM system. Okay, but in case of ArcGIS Pro we required minimum 16 GB to 32 GB RAM. So then only you can able to process this much huge amount of data. Now even the drone, if I say, suppose if a simple drone data, if you go for some simple this plot which you are getting, that will going to reach in 32 GB. I need more than that. So to process those data in the this particular software, it will take a time. So then there is another version that's called Drone to Map, and then there is another upgraded version which will be the future, you can say, of the drone data processing, that is the side scan. Okay, so that's we are going to discuss, and we will see the demo over all this. Okay, so this will be the first part of my lecture. And second part of the lecture, there is a sophisticated software which we call as NV, where you can do a lot of image processing things. Okay, so you know this means the drone is providing you only the data. So now it is your knowledge and the techniques which you can apply over data, and you are extracting the informations. So for that information extractions, NV will get much more image analysis kind of things, which we're going to discuss also in the next part of the session. Okay, So now, okay, so very first thing is we have to know a little bit about the drone, like unmanned aerial vehicle, which is commonly known as a drone. What is the advantage you don't? Why not we can go for high resolution satellite images? Now you know a lot of satellite images are there. Maxar is there. Okay, then Planet is there. So you know what are these satellites? What is the main disadvantage with the satellites and advantage with the drone? That is the temporal resolutions. First, you think this one the first. Second one is the spatial resolutions. So drone is always an advantage in that particular section. Okay, so I'm telling about two satellite agencies name. One is the Maxar, one is the Planet. Okay, and in case of Hyperspectral, proudly we can say in India there is a startup which name also Pixels. They started a hyperspectral satellites also, and which is providing a very high resolutions over the temporal and spatial both. Okay, but still there is an advantage in drone. Why? See, very first thing is whenever I require the data, I can fly my drone and I can acquire the data. This is a very fast advantage we will get from the drone. And according to my altitude, in what altitude I want the data. So according to the altitude, you know, the resolution is also changing. Simple example, satellite. Okay. So if you know that we have two orbits, you know, polar orbits and geosynchronous orbits. So in the polar orbits, whenever we are putting some satellites, we are getting the resolutions, high spatial resolution or poor spatial resolutions. Any idea? Anyone? See, whenever we are putting a satellites in a polar orbit, so altitudes are less, so resolutions will high. But there is another disadvantage. Swath area will reduce. Okay, so the same thing when it will be a geostationary orbit, we will get a very large swath area, but resolution is automatically coarse. Then another disadvantage, an advantage. Polar orbit, as it is near to the Earth, low orbit, so it is taking more time for the traveling to the Earth. So the temporal resolution is more. And once it is in geostationary, you will get very fast data. So that is the, you can say, disadvantage in satellite images. Means at a time, if I want the same spot and locations, I want a high spatial resolutions and high temporal resolution. I don't have any control over the satellites. Where we will get advantage in this drone. Okay, so components of unmanned aircraft systems, you can say we call as a UAV. So ground-based controller and the communication system between the two we are getting, and so you required some kind of licensing, which is provided by the DGCA and the MOCA. So this is, there is a certain criteria is there, like if you are flying 250-gram drones, then you do not require any kind of licensing. But if you are going more than 250-gram, okay, so you require a proper license to fly that particular drone. Yes, some kind of agriculture drone is there, like we are using the spray drone also. So in that it is a more heavy drone, but if there is no camera, so there is no issue. Even there is also there, a VGA camera is also there providing with that, for providing us properly sprinkle over the agriculture, but that is not required in license. So these few things you have to know, but now the policies are very open. Okay, so you very easily know which will be the green zone where you can fly your drone, and that is available by our websites in Government of India. And that is the advantage. Like earlier, flying drones are very much complicated. Now it is going very easy, and this market is going to increase a huge market by 2030. Okay, so I will just go to the next slide. Yeah. So now this is the advantages I'm talking about, which I am telling about drone. So why should you go for the drone? So then I will come to our three different products and the process analysis. Okay, so you will get a clear idea about what is the differences between these three software and what is the processing. First, you see the real-time control. This is the advantage of drone, which is not possible in satellite images. Okay, like any real-time data you want, you can fly your drone, and that time, so like for a lot of data sets we used for flood mapping. During the flood mapping, or just recently, this, you can say, the Joshimore, that incident was happened. So in that scenario also people are using drone and capturing the information. Like any kind of disaster management situation, you can able to, I think mic is not good. So any kind of disaster management situation time, you require the drone data, and it is important. Accurate monitoring. So obviously drone, we will get a very high accuracy of the data. Okay, so yes. Yeah, so we are getting a very high accuracy of the data. So in the drone, I think it's not there. Thank you. Okay. So now what? It's fine. Okay. So now the main important thing is the accuracy over the drone data. So we can able to control our drone data. Okay. So accordingly, we will get a higher accuracy over the data in the spatial resolutions. Like if you see in a normal satellite image, as we don't have any control over the altitude. Okay. So whatever the data you are getting, suppose I'm giving one example. Usually from history, we are handling the Maxar satellite image. So Maxar data. And I try to find out, one of the clients is asking for a Maxar satellite image for East Calcutta Western region, eastern part, East Calcutta zone. So I try to search the data of the Maxars, and I found only 5 sets, which is covering the total Kolkata, but that is other different scenes. So that is the problem with the satellite images. It is high resolutions. Okay, but same time I'm not getting more data. But whenever you are working for the agriculture, okay, so main important thing is time. So that is very important here. So we have to fly the drone the time of the crop growings, because every 5 days the crop height will going to change. Hello. Fine. Thank you. So now, so that is the importance of the drone data sets when we are comparing with the any kind of satellite images. So these are the two important things. If you see here, one, we are talking about the spatial. Another one is we have the temporal. Why spatial and spectral? That also we have the control. Just see in the, what you seen in the first session, what sir is showing you, like he is putting different sensors in their drones. Like one you seen, that is simple RGB it is capturing. Another drone you seen, it is with a multispectral, means blue, green, red, and infrared band also you are getting. And one other drone you seen, that is the thermal images is actually capturing. So that means it is in my control. Okay, so I can do whatever sensors I can able to put, and that is a great advantage over your spectral control. So whenever you have a multiple bands with the higher spatial resolutions, then there is a more chances of go for biophysical parameter estimations, which is very easily you can do. It's not an easy task. Yes, obviously you require a very good knowledge on that, but yes, we can go for that level of analysis. That's why we are actually putting these things like spatial and the spectral, which you have the control over the drone. Now, transparency and less labor initiatives. This is also important. Like if you are sending the satellites, it's a huge cost. Okay, and then to getting a data, to process it, to create level 1, level 2, level 3, different level of products you are creating. Okay, so that is also a huge task is involved. But here drone data is very simple. You capture and that processing, now you will feel it will be very easy. But if I do the same work in 5 years back, it will be very complicated thing. Like if I tell you, if you are experienced with for photogrammetry, okay, so simply what the mosaicing we are doing, so that is we are actually using the bundle block adjustment for that, and that is very complicated. For the type 1 generations, it will be very much stress on your eyes. But now everything is doing in automation mode and you will get direct output. Okay, so that is the how the
So you're not audible. Kindly rectify it.
Oh, it's mute. Sorry. So now, if you see here, why we are using the multispectral, visual, or hyperspectral? What is the difference? First, you have to understand this, because we are going to in a processing. That time you should know the difference. There is a separate lecture I will provide you over the multispectral and hyperspectral during the NV session. But just for this first session, we just let you know that there is a specific use for all these particular sensors. But multispectrals, we have usually 4 bands, and you can go for any visual bands which we said, that is simply for RGB data we usually capture. Some cases we are using the LiDAR sensors. So LiDAR is very good for what? See, usually from this multispectral or visual camera also, we are creating a digital elevation data. Okay, what is this digital elevation data? What is this? Anyone? Any idea? Anyone? Any idea? What is DEM? What is GSM? What is orthomosaic? Anyone? Any idea? Okay. See, you have to know this, because we are going to show you that one. We are going to produce that product. So what is this product? First, you have to understand this thing. Like DEM, DSM, and DTM, we have 3 products. Means usually we created it as an elevation data product. We usually call it as an elevation data product. So DEM and DTM both are bare topographic surface information. What is the meaning of bare topographic surface information? Means we are creating a surface model where there is no other information, only the surface information we will get. Okay, so that means in that surface, if there is any tree, buildings, okay, so you will not able to see in that particular image. Only the surface change you can able to see. So this is we call as a digital elevation model. So terrain model is also same, but terrain model you will get the slope and aspects informations are more clear than DEM. Okay, so this is the DEM and DTM. So both are bare topographic surface informations, and it is giving the informations about the height of the particular area. So from the drone data, the first things which we are going to produce, that is these 2 things are very important. Okay, so after mosaic, the drone image, we are producing these 3 products actually, DEM, DSM, DTM, and orthomosaics. And now the advanced versions, you will get the mesh products also. So all this terminology first to understand, because processing is very easy. Okay, but the use you have to understand. Okay, so DEM, DM, DTM. So this we understand. Okay, but DSM, what is that? It is called digital surface model. So anything over the surface, so that also you want to see over that particular model, then we usually go for the DSM. So now DEM is important for what? So many analysis we are doing over the digital elevation data. Like anything, like if you say, suppose a drainage pattern. Okay, so how the drainage pattern will move. Okay, so where the accumulation zone of the water area, if you want to go this level of studies, obviously DEM is a very important product. Not only for this, lot of products, like if you are generating the orthomosaics, orthomosaic data usually we called is the most accurate product over the any other data products. If you say orthomosaic data products is a very high accurate data you will get over there. Okay, so because the tilt and distortion error we are actually removing with the help of digital elevation data. Okay, suppose you heard about the Landsat satellite, you know, Landsat satellite everyone is, you know, in Landsat satellite it's a 30-meter spatial resolution. And there is a Aster, there is a digital elevation data we have that is also 30 meters. So usually we used earlier times, we are using the help of the Aster, we are trying to do the orthomosaic mapping we are usually do over the Landsat image. The same kind of concept we are actually going to do over the drone data. Okay, so now this, for this, if you see the focus, the LiDAR you giving you the most highest accuracy of digital elevation data. Now, first I'm telling you the few sensors which is providing you the digital elevation data. How we are creating a digital elevation data. First you know that. Okay. So first technique, that is we call as a stereo photogrammetric technique. Using that, we are creating a digital elevation data, and that we are going to show you over the drone. Which drone is actually doing? That is stereo photogrammetric technique. So from there, we are creating a drone, means digital elevation data. Okay. Second way to creating a digital elevation model, that is SAR data. Synthetic aperture radar. Synthetic aperture radar, there's a two-way we are producing the digital elevation data. What is that process? One process we call as a radarogrammetric process. So radarogrammetric process is the same like stereophotogrammetry, which we are going to apply over the drone. That we are usually applied over the radar images. Two same stereo pair radar images, we are creating this same technique to creating a drone data, digital elevation data. There is another technique in SAR we are actually using, that is called interferometric technique. Okay, so where from the two fringe differences, we are trying to estimate the elevation of that particular area. And this is giving you most highest accuracy over the kind of digital elevation. Millimeter level data you are getting from the SAR interferometric technique. Okay, there is one more technique, that is LiDAR. LiDAR is also giving you also a millimeter level of digital elevation data. So now the process of creating a digital elevation data is all these four techniques which I just told you. One is stereo photogrammetry, which we are going to apply over now in the drone data. And because this is the most cheapest, you can say, because LiDAR is very costly product, very costly product. Okay, so LiDAR, flying LiDAR, the sensors is very costly, and flying LiDAR is also very costly. So that's why the DEM level of accuracy is getting very high in the, obviously over the LiDAR. But there is a SAR interferometric techniques also people are using nowadays where we are getting a very high result. But SAR, again, it is complicated, very complicated. If I explain you the interferometry, it is a huge lecture. Okay, so interferometry is a very complex thing. So then the drone is coming, because here it is very easy to create this. Okay, so that's why we focusing over this type of software solutions with the help of drone to create a very high resolutions of digital elevation data instantly. Like I'm just telling you, the most challenging thing is getting high resolution digital elevation data. As of now, the highest digital elevation data which you freely available in the market, that is 12.5 meter allows pulsar DEM. Okay, so after that, that is the Aster DEM we will get 30 meter, 90 meter, and our ICRISAT means ISRO DEM is there. Okay, like this Cartosat DEM, that is also 30 meter we will provide, but not getting a very high resolution DEM. So then drone, using the drone, you can create a very high resolutions digital elevation data of your area. Okay, so that is the advantage we are getting. That's why for which organizations we are helping, you know, like mining organizations. Okay, very recently I went a training to providing them. They want a mining area, is a very small area. Okay, so we fly the drone. Why we fly drone there? Because they want a very high accuracy of the digital elevation data, and we fly the drone there. We created a digital surface model, digital elevation model for them, and then how much they dig it, so that they can sit in the room and they can calculate it also, and how much piles is also there. So that also they want to calculate. So all these things, flying drone, they can estimate. So that is the advantage from the DEM. From this drone technology, we are getting a DEM, a very easy, very high accuracy DEM we are actually getting for my area where we are actually flying. So now this is the advantage of this LiDAR. Okay, so now the hyperspectral data, you will see hyperspectral data. What is the advantage? Hyperspectral sensors, because normal multispectral sensors you will get only 5 bands. In hyperspectral, you will get that particular sensors or satellites, suppose 250 bands. And what is the differences, you know, like if there is no pen, then otherwise I will show you. Yeah, it's there. Where is it? Okay, fine. Board is not there, na? Fine, no problem. Can you please? Here I can show. No problem. Yeah. See, first you see what I try to explain, you know.
अरे 27,000 फीस आपको
That is,
96
we are
हजार
going to show you in the practical,
अगर एक
in
बार
the,
चांस
in
है तो
the,
आप
in
वेट
the
कर दो
software only. But you have to understand what is the differences. This curve, this we have to understand. Suppose these two things we have.
ये सब बीच में कोई ऐसी थी क्या दो सीट एक जनरल थी इसमें चांस नहीं बनेगा
Suppose if I take
बीएससी के चांस ही बनेगा कि अगर नेट आ
spectral
जाता
curve, we can
नेट वाले
create for the two different sensors. One is multispectral, one is thermal, over a same object, which is called as a vegetation, suppose. Okay, so how it will be looking, you just see. This is the difference. If you see, this curve is much more smoother, which is very accurate. So if you have any idea what is we call as a spectral curve is like we are actually means this object, they have unique spectral response pattern, which we are identifying with this spectral curve. So in case of hyperspectral, you will see which we call as the exact vegetation spectra, that is something looking like this. But in case of multispectral, you will get a very sharp. You will not able to understand the spectral curve exactly. Why? Because the bands. Spectral resolution means more the spectral bands you have. Okay. Suppose in multispectral we have 5 bands, as you see, blue, green, red, near infrared. Okay. So if I click over on one pixel, so it will take the value from all the 5 bands over that. Suppose band 1 value is 8, band 2 value is 16, band 2 pixel 1, band 3 pixel 1 value is 17, band 4 pixel 1 value is 24, band 5 pixel 1 value is suppose 8. So if I create a graph, so it will be something like this. But the same thing if I create over the hyperspectral, the 1 pixels for the 250 bands, so you can get a very smoother spectral curve. So that's we are actually trying to focus over in agriculture, mineralogy, wherever we are, the concept of identifications, we are going with the hyperspectral, just to think like that. Whenever you want to identifying something, then we can go for the hyperspectral techniques. A very great example of this is over the moon, we identifying the water using the same technique. Okay, but here our focus is over the agriculture, vegetations, health conditions also we can identify, water stress or any kind of stress we can identify. Okay, whenever you will get idea over these things, I will show you the processing, so that time it will be much more clear to you. Okay, so now these are the few applications area which we'll see where we are actually using the drones extensively, like for the forestry. If you see, this one is actually called cross profile picture. From the LiDAR images also we can create this type of cross picture. So we just say for utility mapping. Okay, this is basically for the airborne LiDAR. There are sensors, you will get a picture like this, like UAV sensors. We are actually putting just like thermal here, same. Usually put the sensors over the LiDAR, which will collect the data, and you will get a data set something like this. And that also you can able to process in NV. Usually I went for one training in it is in Roorkee. Okay, so Roorkee is a very IIT Roorkee is a very good lab. Okay, geodesy lab. So they have their own LiDAR sensors. So there first time I got the chance to process those data. Their UAV data I processed in our NV software. So NV, you have a free you can say LiDAR data processing software. Okay, so that is coming with, this is called NV LiDAR. So there we usually create this. You can see these 3 things. Now this is basically a cross profile of that particular LiDAR data. If time permits, I will show you that particular demo. Okay, but this is same thing we are applying for the utility mapping also. Now here, there is few things which we are nowadays doing, that is, see the solar inspections. Okay, so if you see solar inspections, not only for the site suitability analysis, from the drone data, we estimated where the solar plant should be put it. So that few of my colleagues from vessels, they are actually doing this work. Okay, and not only that, see same kind of thermal images, thermal sensors, you can able to see which is the damage panels. We can identify. Okay, so using the drone fly, we can identify those. Nowadays, we are applying deep learning inside that to identifying those damage planning in automation mode. Okay, so deep planning modules is also there. It is coming with the ArcGIS Pro. So it is actually a huge thing. So many things which will come if I started. So just I will telling you what are the latest technology which is coming with the drone. Now deep learning, machine learning is also coming to the picture. So now this is the mining. For the mining, as I told you, see the mining area. Okay, so how much depth? Accordingly, you can classify the image, and that from the drone it is possible to do that. Same thing for agriculture, which we will going to show you now over this, some sample data over the here in IRI we got. So there you will see there is some kind of spots which, like usually farmers are spreading pesticides for the full field. So now this is we call as a precision agriculture, the new technology which is came. India, it is very less, but now so many startups, they are actually working over this precision agriculture. They installed the sensors, and that they try to correlate with the drone and the satellite images, and they are providing the informations to the farmer in their local languages. They created an app. Satyuk Analytics, there is one organization in Bangalore, they are working with this. Okay, so, and that is a proud thing for us. Like in India, so many startups, they are actually working like this type of works. Okay, so that is kind of analysis which we are, it is not only the research, we have to provide these informations to the farmer so that they can benefit. But the precision agriculture technology is very costly technology. So they make it cheap. Okay, so with the help of drone and the satellite image recycling techniques, they are also trying to identify the crop analysis, which we are trying to do it over this particular MV software we will show you. So now industrial inspections, if you see here, so many big companies are there, like their thermal plants, nuclear power plants. Okay, so if there is any kind of leakages on there or not, so that we can estimate. Just yesterday I showing in LinkedIn. Nowadays for the bridge inspections, bridges are there now, so there is a cracks will be there. So if there is any kind of cracks, automatically it will highlight it as a heated map wherever there is a cracks, just from the drone flying. So using the artificial intelligence, they are identifying those cracks. Okay, so that is how this technology is actually moving towards. And now we come to the three things we will going to show you now. First things which we called as a side scan. So this is the latest technology, which is you can say the future. So why? Because it's, we just see here, it's a web and cloud. What is the advantage of any software in a web? Like as I told you, ArcGIS desktop, you are installing the 4 GB RAM systems. ArcGIS Pro, you require 16 GB RAM systems. So the hardware dependency is not required whenever it is in the web. Understand what the technology is shifting? So now all the softwares like ArcGIS, ArcGIS Pro, you are installing in your system. So now after some time, it is not required. So you just require a login ID, you just log in, start processing in any software, any system. That because the advantage of the web. So ArcGIS, side scan is giving you that option. Second, if you see here, drone flying app included with the side scan means the side scan not only process the data, it can control the drone also. Okay, so whatever you seen in the field, like start, flying path, and whatever flying path it will cover, and after that it will come back to them. So it can control the drone also. The side scan is that technology. Okay. Next, input data. You can see data. It can produce 2D, orthomosaic, DSM, DTM. Now you understand what is DTM, what is DSM, what is orthomosaic. So these three things you understand very clearly. So what we are going to create with the drone data, first thing is the orthomosaic, DEM and DSM. This is the three products we are producing on the drone. Okay. And if you have the multispectral, then we can go for those analysis, multispectral or hyperspectral. Then we can go for the crop health or NDVI you want to calculate. So those all things we can able to do. Okay. So now if you see within the data products, there's two types of data products it will produce. One is 2D product, another one is 3D product. What is the differences? 2D you will get orthomosaic, DSM, TTM. This is a 2D it will get. Okay. 3D you will get three things. Usually we call as a point clouds. Another one is the mesh. So point clouds, if you have an idea with the LiDAR data, so LiDAR data, what we will get? We will get the point cloud only. So over the point cloud, we created a 3D, which is just like a realistic model you will get, that we call as a mesh model. So mesh is something looking like a realistic view of that particular earth object. So here you will going to produce these two things. Like one is the mesh model, another one is the cloud points also. Now, cloud connections from the flight app is possible in the side scan. Drone fleet management also possible. Analysis capability you can do. So now drone to map. There is another software which we called as a drone to map, but drone to map is a desktop. It's not working in a web. You require a certain system to process this data. Okay. So now it will process it. Here you will get 2D and 3D, both the products, but not this all things you can able to do it there. But we require this two only. That is very important. That is 2D, orthomosaic, DSM, DTM, cloud points and mesh. Both you can create in drone to map also. But in drone to map, you can create one thing that is called NDVI. Like multispectral images you can able to process inside drone to map. Okay. So that is side scan. Next versions it will come. Okay. So that is the only differences with the drone to map with the side scan. Now there is one more software which we call as a ArcGIS Pro. So ArcGIS Pro also you can create 2D products, but 2D within 3 products you can create. What is those things? Orthomosaic, DSM, DTM. You can create in ArcGIS Pro also. Yes, you can't create this mesh model and point. Okay, so I will show you one software, what you can produce, and what is the output and how we're going to create the outputs. Okay, so that we're going to tell you. So now, if you see here, basically we'll try to focus. When I came that time, I thought I will show you only these 2 products like drone to map and the side scan. So that's why I just put it over here. Okay, so if time permits, then definitely I will show you the Pro also, because Pro is actually, you can say, in one place you can do all the kind of image processing things. Okay, with there is some kind of limitations over the drone data, obviously you can do, but this drone to maps is particularly developed to process the drone data. Okay, and side scan is the advanced version because it will produce everything in cloud. How? See, from the starting from the flight plan, means how the drone will fly. So that you can control in side scan. So once the drone will come back, it will send the total data to the cloud. Okay, and whatever the products you want to generate, just you need to tick on, and then you have to send to the cloud. cloud it will automatically process, and this data output you will get directly in your mail. Whatever mail ID will provide, you will get the output directly in the mail. So this is how side scan is actually working. Okay, so human intervention very less, accuracy very high, processing very fast. Why? Cloud platform. Now come to drone to map. So drone to map, it's not a cloud platform. So whatever you will going to process, like morning you fly, you capture the data, now you come to the lab, you download this data first. Then you can process all those things. This is the difference. So this downloading and processing this data is a huge amount of data. Okay, and that is going to pressure on your system. So you require that much good system to process all these data sets. So you have to think about the hardware. In case of side scan, you don't want to think about the hardware. But here you have to think about the hardware, because you are going to process your data in your system. So you require a very good workstations to process a huge number of data sets. Now you come to the ArcGIS Pro. So this drone to map, it is processing times, suppose it will take 2.5 hours to process this all data, to converting in DEM, DSM and DTM. That same time, it is going to compute in side scan, it is 1 hour. And that is also totally processed in cloud. So in your physical system, there is no issue of data size, data storing. Okay, so it will not getting any issue. But in drone to map, it is. Pro, not only it is giving pressure on your system, the processing time will be 3 hours. Even the 32 GB RAM. Now just think. Okay, so this is the difference. So before the data processing and analysis, you should know what will be the suitable for you. So accordingly, you have to think. Obviously, the side scan is the latest technology, so that's why you will get these all advantages. Okay, so there you will not feel that you are doing or creating some kind of data. I'm just showing you in that so that you will understand. Okay, so this is the workflow, like plan to capture, process and management, disseminate and collaborates. So that is from the ISRI cloud we can do. Like side scan, what it is doing. First is flight plan. So see different types of drone you can fly, you can capture the information. Second is processing manage. So you just see this is a surface model, orthomosaic, illusion model. It will create. It will send you the output. Now, if you want, you can send this data to our cloud and you can create your app. Like, you know, tomorrow is our UC. If you come, then we will show you. So we developed means whatever the processing would be in a drone. So that drone data, it will take it to in the cloud. Okay. So before taking the cloud, we did the analysis over the NV. Okay. So we calculated 21 different type of indices over the hyperspectral data, and whatever the results we are getting for some different particular crops, that we can create a dashboard. Or not only dashboard, we created one app. So in that app, in the mobile, a farmer can carry, okay, and he can go in exactly that locations where this area is actually affected. He can give the pesticides and he can come back. So that app creations. So the app creation is also possible with the help of two things. One is either you can go for the ArcGIS Online or you can go for the ArcGIS Enterprise. So for creating these apps, you need not require any kind of coding. So totally these apps you can generate by yourself, just clicking the widgets, whatever it is required, zoom in, zoom out, add data, field editing, whatever you want, you just add it, send it to your mobile. Okay, so whatever your mobiles are there, Android, which versions mobile, and you can directly collect collections of your field data, and that is directly upgrade in your server. So that's the total picture. Means drone will fly, According to my flag, it will capture the informations, it will send the web. Okay, so whatever data is captured, it is sent to the cloud and it will process the data. Data will come, we get this data, create a web app, and we will send this web app to the farmers. So the farmers can update that particular place where it's required the pesticides. How this technology is actually involved. Okay, so like in foreign countries, people are actually doing this work for the precision agriculture. In India, it is still developing, but it is the future. So let's see the demo so then we can get an idea. So I don't know why it is not. Yeah, this is okay, fine. So this is the very first things of this, you can say, how we control or design the flight plan. Okay, so first we will see it here. I will just play it. So you just see here, this is how much area you want the drone should fly. You just draw like this way. Okay, and this is, you just see, this is a flying path. Okay, and this, you just see this flying paths. You know what? This is accordingly your height. Suppose if there is any kind of hill will be there, so your flight plan, it will be something like go up and then go down, and it is automatically designed in this. Okay, either few softwares will be there which will take in your automation, and few softwares you have to manually decide what should be the exact altitude from the particular ground height. Okay, so altitude if you fixed, and if your altitude automatically changes, so accordingly your drone is also going to change. So this is how it is working. Okay, so let's see. So this is how these flight plans are decided. Okay, and here this is a project flight plan name you are providing. Okay, and then you just simply save. This is a flight plan is ready. Now you can go to the particular offline modes and you can give some informations. We come to this particular, to controlling the drone, you have to check few signals. Okay, we will show you. Those are the few signals you have to check before fly this drone. This is we are preparing the flight plan. First is the flight plan. The same thing which you did in the morning, you are doing over some DJI softwares. Okay, the same thing which we are going to handle in this side scan also. Okay, so side scan, we can able to see. Advantage of this is DJI, that software, you are able to controlling the particular flight plan only, but you can't do the analysis over the data. But here you can able to control the flight, and as well as you can able to process the data sets also. So let's see. So this is the checking, like it will going to check. See all these parameters, once it will be in a grid, then only it will activate it. Okay, your flight plans means is ready. Just see here, execute automated checks and takeoff. So now if you click on this takeoff, so now this is the flying. See how this drone is actually flying and how it is capturing. You can able to see in the screen also. Okay, so this is directly, it is controlling your flights and it is capturing the informations and it is sending to you. So to total this flight plan is actually captured like this way. Now we will going to show you this one, which is side scan dashboards. Okay, so see here DJI Mavics, which is data which is uploaded in automation mode. Okay, so here whatever products you want, so that is a single click only, just processing. You have to add the data and you have to process. That's all. Like here it is going in automation mode only, but some cases you are flying with some other drone which may be not able to control this drone with a side scan. So in that case you have to upload the data separately. That is the difference. Few drone which can control by this side scan, not the every drone it can be control. Maybe in future it will be open. As of now it can control the DJI drones. Okay, so let's see this video. Yeah, so this is a kind of a dashboard. Okay, so just see here, so where the area which we are actually inspects, so this is the inspection program, and you just see this is we called as our dashboards. So directly, suppose you just think, as I told about the solar panel. So whatever the solar panels we captured, if there is any kind of damage, so if drone will identifying that, automatically it can informations giving in the status in the dashboard. So how many panels are actually damaged and how many panels are actually in the right things. Okay, so that things which we can capture and create a dashboard like this in the side scan and with the help of ArcGIS Online or Enterprise. Okay, so this is how this cloud platforms is helping us. Now I will show you the real how this data processing in the side scan. This is the actually the steps, but here you just see here. So this is actually the side scan looks like. Okay, yeah, this is the side scan sites is looking like. So how will open? So I will just cross it. I will show you from the beginning. So this is, you do not require any software. You just simply log in with this ID and password. Okay, so simply just load your ID and password. Okay, so I already log in, so it is going to show me directly this, or if you have your login ID, simply log in. This is a side scan, it will open. Now here, see, we have sorry, project. One minute. Yeah, so this is the project. Okay, so this is suppose a village project which we have it here. Okay, so you just see here. So I'm just taking you to all projects. First, this is the all, how many projects you want. Okay, so here another advantage you just see. Drone to map, ArcGIS Pro, any drone software, you can process at a time one project. Here side scan multiple projects. Okay, so that is the another advantage of this. Like, what is the meaning? You understand? You captured the drone data, you came back to the lab, you upload the data, and it is giving the processing. So by the time the data will not finish the processing, you can't take another data you can give in a process in the same software. You can't do it. Side scan you can do that. Understand the advantage? Multiple data. Whenever you have a huge data, multiple data, and you want to process in at the same time, go for side scan. Okay, so that is the thing you have to understand. What is your requirements? Accordingly, you have to select the software. Okay, so now you just see here. Here we have two different projects. So I just only one projects I just opening here so that you can understand. So see here. So this is the village 1 project. So I'm just clicking and opening the village 1 project. Okay. So here you have the layers, files, okay, and the photos. Yeah. So this is less one. Better you can go for that project. This one, yes. Okay. So you just see here the photos we have 391. So if you want to click this one, so you can see all the photo. Okay, so if you click over any one the photo and just see, you can able to see that particular photo. And if you click on the next, so you can able to see all the different photographs, whatever it is captured, you can able to see it here. So you can click on this. So this is the just checking the photographs. Next is, see here there is options to upload the photographs. So if you are not controlling this side scan, okay, directly from that particular drone which you are capturing, you want to upload that drone, maybe it is not directly linked with this particular side scan, so you have to upload the data separately. So this is the process. Okay, so here just down there is options. We have the photos. If you click the photos, so now upload folder and the photos. What is the difference? You know, if you go in a photos, you have to select one by one photos, and if you go in a folder where you have all the drone data, you just simply select that particular folder. So automatically all your drone data will upload over there. Understand the difference? What is the differences of this upload photo and the upload folders? Okay, so now here we have this elevation data. So this is how it is created. See, from this drone, what we are getting the elevation products. So these products, how it is created, I'm not going to give in a creation, so it will take 1 hour time. So your work, you just see the data analysis, how very easy over here. First, I will show you this. So then after that, you will feel drone to map, little complicated. And if you go for ArcGIS Pro, more complicated, because those are the old technologies. Okay, but here you are not do anything. Just see here what you did. You capture the drone data, you kept in a one folder, you go here, you click on this, click on the photos, select the folder, upload, close. That's all. So once I uploaded, so see my all the data sets are came here. Next thing what you have to do, see here down. What is called? Are you able to see? It's written process. So that's all. See what are the data we are getting after this processing. See whatever written it here, contours, elevations, hillside, orthomosaics, DEM. See under the DTM you will get DEM also. Okay, so all these products it will going to produce just a click. Understand, ma'am? You need not to do anything here. You just need to upload the photographs and you have to click this button called process. That's all. That's all. And you will get the results. I will show you one by one. So first I will switch off this. This is the orthomosaic. See here, if I just switch off this, so this is the orthomosaic products of that particular drone. This is the first. See how we'll get, I will show you the mail which I received, okay, after processing this. So I will open this. See, this is a side scan. Are you able to see side scan? This is the mail you will receive. Once you click the process button, okay, once you click this process button, so it will see something will going to start. So it will take 1 hour time. It's a huge data. Suppose I'm telling you, if you go for a huge data, it will maybe a more time, but 1 hour time it will take. And during the process, if I didn't want to click, because if I click, it will start processing again. So if you click, so only thing you need to give, that is your mail ID. Whatever mail ID you want to receive the products. What are the products? DEM, DSM, orthomosaics. Okay, so that will come to your mail directly. This is the mail where I received this file. Okay, so this is the file. So if you click on this, you will start downloading that data in your desktop. You can save. Here you have options here. If you give export, so you just see these are the products which will be there. From here also you can download. See all the products. Okay, you just simply click on download. Data will start downloading here. Okay, so this is the very easy way to process the DEM, orthomosaics, and all those things. Suppose if I switch off this one, I want to see the contours. Okay, so accordingly the contours will going to produce. Now, so here one thing you have remembered. So one is DTM is there, so then only you can select for this contours. Otherwise, DSM contours will be going to very hazy things. Okay, so here you have to select the DM or DSM. So accordingly, you have to check of this. So usually over the DTM, we always check the contours. Don't be confused when you are going to create a contours over DM or DSM. So you have to create contours from DM. Usually contours are bare topographic surface inversions. Okay, so that's why. So now this is the contours which we provide. Okay, so like that, orthomosaics you will get. Okay, so this is how the drone to maps is work. Nothing is there. It's very simple if you go for it. Okay, now we will show you over the drone to map. Okay, so I will just open the drone to map first. So now drone to map. So this is the drone to map. So both way you can open. Either if I go with this, okay, then we have to add a project, or else we have the project. I can directly click over here. So this is the drone project. One minute. Some multispectral samples. Okay, so directly click the project. So this is a project. So what is the concept of projects? I'm just telling you, then you can get an idea. So in case of ArcGIS desktop, if you are working, so desktop and ArcGIS Pro, there's a huge differences. So usually in ArcGIS desktop, you can work in only one project at a time. Means one window, one work you can save. Okay. ArcGIS Pro, you can save multiple multiple analysis in a one project. So that is the advantage of your ArcGIS Pro. So that's why we usually called it as a project. Why? One example I'm just telling you, like my PhD work, I have a separate part. Okay, few part I did analysis over anthropometric heat flux, few part I did over the SAR data analysis, but all these things I saved in a one project. Why? Suppose after 6 months, where I did my other work, so I have to search. So that is not required, because all my analysis will be there saved in a one project. So that we called as a project file. Okay, PRJ file. So PRJ file is also there for the drone to map also. So drone, related to drone, you have a multiple analysis you can save in a single project. Okay, so that is the what we are called it as a project. So if you see here, see what is the meaning of this, this is, we see here 2D maps and 3D maps. Are you able to see? So 2D maps and 3D maps you can open in a single page. I will switch off first all these things, so then you can get it. So this is, first you have to understand a project. So project means in a single window I can control multiple window, and that is also over 2D and 3D, which is not possible in ArcGIS desktop earlier. Okay, means once you open ArcGIS desktop now, you can't control 2D maps and 3D maps simultaneously, but here you can do that. Even in drone to map also you can do that. So this is the drone to maps I'm just showing you first. Okay, drone to maps also you can able to control this zoom in and zoom out power over in a both window in a simultaneously, and that is also we call as a geolinking. Geolinking, you know what we are doing? Geolinking. So usually whenever we are comparing the two different pixels value, so we need to do the geolinking, and you can do the geolinking in ArcGIS Pro and here also. So that is the tool which we call as a view link. Okay, if you go in a view link, scene and center if I do, so then both window I can control together. So just see here. So this is, I make two different windows together. And now you can control these two together also. Okay, because it is, I don't have now drone data sets in a digitalization model, so that's why it is not showing. But this is, see, if I zoom in somewhere, okay, if I click on this view and center and the scale, so see, that is not geolinked, so that is not showing. But if it is geolinked, I will show you in a Pro. It will be definitely work together. Now we come back to the drone analysis. So here also you have the same options to process your data. So few data sets, what are the data products is actually generated, you just seen here. So you can create not only the orthomosaics, DEM and DSM, with that you can create NDVI and SDVI also. NDVI is normalized differential vegetation indices. For that, what the bands you required, infrared band is very important. Infrared and red band, these two bands are very important. So soil adjusted vegetation indices is also there. This is SAVI. So that is, you can say there's a lot of indices also you can able to run directly inside this. Okay, so see here, first products I'm just going to show you. This is a project data. Okay, so this is the very first project data, means add data. So how we are adding this, you just see here, this is a project now. So if you go in a project, you need to browse your data, or you can click over this add folder. Same options like side scan, it is same. Side scan, you have add folder or add photographs, same options over here. You just see here, add images, add folder. Best option is always go with the add folder options. So you need not to select one by one images at a time. Click whatever data sets you have for the drone, you kept it in one folder, select this particular add folder, connect it. All data will going to process in automation. Okay, it will upload. Same way I uploaded it here. I will show you a total video because this is I have a recorded video. So I will fast forward. I will show you total processing of this. So this is your drone images. This is why I'm showing, because this is the here in agriculture, this land data sets. So that's why I'm just going to show you that. But this processing time is much more. So that's why not able to process over here. Video capture I'm going to show you. So after this, see, if you click over this, you can able to see the image informations also for the each informations. Okay. So now this is the project ones. So I'm just switching off this. Okay. And now over this, once you have uploaded this image, okay, so in options you have a various options to create what product you want. Okay, so see here you have to select over here. Side scan, no need to do any selections. You can go whatever, you just run, click processing, it will create all the products which is showing you here. Okay, here you have to select whatever you want, whatever you don't want. So that adjustments, 2D processing, 3D products. Okay, so whatever the products you want, okay, you just simply select that and click on OK. That's all. So once you selected these products like SLPK flight for the cloud products I want, 2D you want what, okay, DSM you want, click create DSM, it will create. You want DTM, click create DTM, it will create. Simply click on OK. That's all. Now you can go to start. So once you start, you will get, this is the first results, orthomosaics. So this is, as it is a multispectral data, you can change the band combination. So if you see here, okay, so here you will get all the bands. So if you want a true color, if you want a false color, so accordingly you can select. So here we have in that particular sensor, because this sensors is actually giving you the red edge bands also. So that is also there. Okay, so this multispectral, if I want to create false color composition, infrared, red, green, we can put a combinations and we can see. Same process if you want to apply or means estimated the NDVI, so that also you can able to create over here. Okay, so one of the example on this, this is the going under that, okay, analysis. Okay, so you will see here, this is the indices you can calculate over the image. So if I showed you, see, if you click over NDVI or SNDVI, whatever you want, you just see here, it is telling you the band information also. Which band is required for what particular index. Okay, so you just see here, this NDVI, you require this too. So if you go here, you can get, suppose for the red edge shift, see, for red and red edge band. So this in ArcGIS means drone to map, we have suppose 1, 2, 3, 5, 4, 6. Okay, 6 indices. If you go this in ArcGIS Pro, you will get 24 different indices directly calculation. Okay, so this is we call as an enhancement techniques. So maybe you don't know about this enhancements. There's 2 things in digital processing we are actually applying so a lot. One is digital enhancement, then digital extractions. Okay, so here we have less options because it is mostly designed to focus over the vegetations. But if you go in ArcGIS Pro, you will see here over the vegetations, how many you can apply? 6. But if you go in ArcGIS Pro, you will see, I will show you, we can apply 17 different type of indices over the vegetations only. That is also, you need not to do anything, just simply like this. You click on this, select the bands, you will get the results. But that is sensors sensitive. Means if you are using the Landsat 8, so accordingly that sensor specifically it will activate it. Okay. So if you see here, so this is the way of how we are actually producing this. And now here you can create a spectral signatures from this also. And see, this is the from the ground control points, means wherever we are extracting. So this you can simply create a spectral curves over this also. So that is how the drone to maps is working to the picture. I will show you very fast the total processing in a video mode. Okay, so then it will be much more clear to you. Okay, first is this one. Okay, so this is one of my lecture. It is there in the YouTube also. Okay, so that's why I just make a fast forward and I will just show you. This is a very fast thing. Like you just open this first drone to map, and now you see I'm just going to add a folder where I have my data. Okay, so just simply do this. Okay, just see it. Yeah. So I will just click on this add folder connection option. Yeah. So see here, this is called templates. So I just showing you element 1 minute. So templates is like what you want. 2D data processing you want to do only, or 2D, 3D, whatever you want. So accordingly, you have to select the templates over here. Okay. And if you see here, if you want to process the multispectral data like blue, green, red, and near infrared band also, if you have, then you can go for the multispectral processing. Okay. For the thermal data, it's a separate template also there. Okay. So in multispectrals, once you are going to select, so then you will get that indices options, all these things we can able to apply over the data. Okay, whenever you have the multispectral templates. Now you just see here. So I'm going for the processing of the 2D products for this particular demo. So you can go for this. See, this is a add folder connectivity. See the image folder. What I'm doing to, wherever I have my data, I will going to select that particular folder over there. Okay. So once I connect this, I will click OK. Automatically, all the drone data products will going to upload it. Okay. So you just see here, if this is the data where we have my data sets. Okay. Solution drone. I just simply click on. See, don't click on this folder, then it will be showing empty. So click on that drone. Automatically, it will upload all the images. So this is how the images will upload it. Now we'll go to the next. You see here. Okay, so this is, if you click here down, there is, you have to give a project name. Like as I told you, multiple projects you can do in a same place. So first time whenever you are opening, you have to give a project. See what I showed you, two-way. Two-way means already created project, how will going to open? That I just showed you. I already created a project, I double click it, it will open. But whenever you are opening your first time to collect the data from the field and you want to do the analysis, that time you added the folder and then you have to give a project name. Okay, so that's only I'm just going to do it here. Just see here. So I'm just giving a name where I have my data. So simply click on OK. See, this drone data is my project name, and simply click on OK to save it. Wherever you want to save this particular project, you can give this location. Otherwise, it will go directly in a, means whatever the wherever the project will going to create, it will directly go to the C drive. Okay, so that's why you have to select the drone. So now I'm just simply selecting this folder and click on this create. Project is created. Okay, my project is created. Yes. Yeah. Yeah. Just 2 minutes. This demo finish, then we will take a break. Yeah.
Doubts if they're having in your next.
Which one?
If they're having some doubts, maybe.
Yeah, sure. No problem. Yeah. So see, this is the very first things which we are going to see. Once you open the drain, then you will get image like this. So this is your flight plans and your point locations where the images are there. So you know the process of the drone overlaps. It's same like aircrafts. like it's 30% side labs and 60% overlaps. Like that, we usually capture the images. Okay, so now you just see here, if I just go a little fast, see, this is the same thing which I showed you that time in side scan. This is, if you click on each dots, you can able to see the each images. And if you click on this right side one, so one by image, it will going to show you. Okay, so now the next, you just see, I will just make little fast forward. So this is the options which I told you that time. So in the options, you have to select what are the products you want. That's all. So here you just see I created the DSM. I will just play it. So see here, I play for these orthomosaics. Okay, create DSM. This is for the 2D products. I am first going to show you. Okay, so 2 products we're going to create. What is 2D products? DSM and DM, and 3D products is a mesh model. Now we will going to show you what is the mesh model. So here I will going to generate the mesh model products also. So let's see. Okay, so in the 3D, if you see here, I created this mesh model. This is SLPK file. So that I will going to check on. So you just need to check on, that's all. Okay, so here coordinate systems, whatever the coordinate systems you want, you can fix it, and rest will be fine. You can simply start processing from this. Okay, so that only I will going to do it. You just see here. Okay, so yes, I just click started. Okay, so I click started. So see, you just see down there is one arrow, 0% it is showing. So it will. So one more things you can do to improve your work, so that I forget to tell, that is the import your ground truth. Suppose if you have some ground truth data and you want to improve your accuracy, then you can import it for this. So see here how to import it. So this is the process. You can select this import drone to maps export files, the Excel files which you have for the local means during the collections. Okay, usually we collect some GCP points to recorrect our data sets. Okay, so that's points you need to upload. Okay, so just see here I uploaded those points. Okay, so this is the GCP points which I just uploaded, and then you will get the results. Just see here. So now I started importing those points. Okay, and these points will going to start processing. It will take almost 2.5 hours time. So that is the differences with side scan. Okay, so here, because it is not processing in the cloud, so, and at a time one project you can run, multiple project like side scan you can't do. Okay, and you just see here now it is start processing, and it will take one by one. First it will do the adjustment. This is called bundle watch adjustments. If you know about the photogrammetry, then you can understand. So otherwise you just type what is called bundle block adjustment. So this is what the images is actually adjusted first. Okay, the tilt and distortions will remove from this. Then it will create the dense matching. Then 2D products, whatever I selected, like DEM, DSM, it will, and DTM, it will going to produce. And then finally it will going to produce the 3D products like this mesh data. Okay, so let's see. I will just see, this is the first. See, once this data is ready, so you will get a DM. So this is a digital surface model you will get. Okay, like that you will get other 2 products also, but orthomosaic it will take a lot of times. Okay, like not this is actually fast forward video. So it is actually, if you know, if you see down part, that you see it is a recording time. So if you see the recording time, it will take almost 1 hour time to finish, because it's very small area. Okay, so you just see here. So I will just fast forward and come to the results, and you just see now digital surface model, digital terrain model is ready. Okay, so one by one products will going to ready. The same thing you have to do now. Okay, to creating the digital surface model from your RGB data is not required any infrared informations. Okay, so now you just see here, you will get, this is called mesh model. See, under 3D maps I'm going to show you this, what I'm showing you over the 3D, and this is the 3D mesh. 3D mesh is something looking like exactly whatever the images it is there, that we call as a mesh model. Okay, it's a kind of a realistic view it will provide. From the LiDAR images also we are doing. Okay, so that is the process of how we are process these data sets. So this is up to that. So next we'll come back, then we will going to show you ArcGIS Pro also. Okay, thank you very much. So इसको stop करना है क्या? रहने देते हैं. Yeah. Where is this one? No, pause status. Yeah, I pause it. Yeah. ये थोड़ा सा ये लेना. Yes.
You shared your screen.
Yeah, sure. Okay, we'll start. Okay. So now we will see the one more process over ArcGIS Pro. As I told you, this is a little old technique. Okay. So usually now we move to the side scan, but some cases ArcGIS Pro, as ArcGIS Pro is actually very strong software for other processing. Like here, it is not only for the drone data. Okay. So like ArcGIS desktop you're using. So ArcGIS desktop, you can think that we usually know ArcGIS desktop is GIS software. Like that, we have a concept. Okay. But in this ArcGIS Pro, you can do lot of image processing things. Okay. So that is, you can say, the satellite data automatic pre-processing techniques, which is available with this particular software. Okay. ArcGIS Pro is capable, is a sensor specific software, like some kind of satellite products. If you know about the satellite data, so you know there is a differences between the satellite data and satellite products. So usually satellite products is some pre-processed data sets. Okay. And satellite data, which is coming in a different level, like level 1 product, level 2 products, level 3 products. Okay. So what this NV and ArcGIS Pro, what it is doing, it is called sensor sensitive software. So, and what is this? This is kind of a smart software which can read the metadata informations from the metadata file of that particular satellites, and it can do some kind of pre-processing over the data. So now, which we're going to show you just after this is the NV. So NV is a very much more powerful than image processing than ArcGIS Pro, but ArcGIS Pro is slowly moving towards that particular capabilities. Okay. Here in Pro, what is the meaning of sensor specific? You know, like there is some kind of satellite space agencies, they are providing a data with some specific kind of bands they are actually providing, which can process directly in this type of software. That band we called as a raster product bands. Okay, so raster product bands, as of now, any ISRO data, I not found any raster product bands because still they are not produced that. But yes, for the JAXA, European Space Agency, and NASA, whatever the satellite data you will going to produce, so they have these particular types of raster product bands, and those bands you can directly process inside this. So that is the advantage of, you can say, ArcGIS Pro and NV. And once you do that, so many things you can go in automation mode. that is from the layer stacking. Okay, so if you see the layer stacking process there, it is showing the band's name will coming by name. Okay, so band's name is coming by name. It's actually a great advantage. Okay, so you know which band is what. In earlier times, whenever we are doing the manual layer stackings, so then we don't know about what band is what. So we have to remember, or we have to see every time what is the band combinations. Accordingly, we have to create FCC or false color composite or two color composite. So how many band combinations we are actually know? How many band combinations? Any idea? How many band combinations you mainly use? Like false color you used, two color you used. Any other band combinations? Can anyone tell? See, we are not using only the true color and false color. So many other band combinations also there. And whenever you go in hyperspectral, so you can try with the different bands always. Okay, but in multispectral, in general, I'm telling you, we are actually using a multiple band combinations to identifying a different object. Even for the agriculture or water body, we are separating some kind of band combination which is called as agricultural band combinations, which is known as shortwave infrared and red. If you put these band combinations now, so very easy way, you know, just download the Landsat image of the two image. One is before flood and after flood. And what you people are doing, mostly you are going for the false color composite, infrared, red and green. Don't use that. Use shortwave infrared and green, and then see before flood and after flood image. You just compare. Within a second, you can identify the differences. Where is actually the flooded? Not doing any analysis, just changing the band combinations, you can identify this. So that's why this type of band combinations also ArcGIS Pro we have a lot, like 8 different band combinations. It is automatically there. You just need to select that. Automatically it will change. Okay, I will show you one. So over this, our main focus as it is drone analysis. So I'm just going to show you only this part. Okay, because ArcGIS Pro, it is a separate total training. The imagery, if I'm going to show you in ArcGIS Pro, it is never ending. Okay, so but our focus is here only to focus over the drone data, how we're going to process in ArcGIS Pro. So if you see here, yeah. Oh, wait. Okay, so I will just make little fast forward so that you can get an understanding. So this is an interface of ArcGIS Pro. If you see here in my software also, I have this. This is in general whenever you are opening ArcGIS Pro. So this is, it will looking like this, not like ArcGIS desktop. So what you have to go into open, the first thing is the creating a project. So creating a project is like that. So we have 3D and 2D templates. Okay, so if you want to do any kind of 3D analysis, go for the global and local scenes. 2D analysis, suppose I am just opening here. Okay, so project 3 and okay, fine. I will just click on OK. And see, my map window will come now. So why I'm showing this? Because to tell you the understanding about the projects. So in a single projects, I can add multiple maps layers. You just see here, this is the one map layer which is open, just same like in this. Okay, so if you want a multiple maps, simply go here, click new maps, and see another maps will come up. So simultaneously we can work. Means if you want to do analysis here, you can do analysis here, you can do that. And if you want to make a separate window, yes, you can make a separate window. And if you want to make a connection between these two, yes, you can do that also. So that is the advantage you will get in ArcGIS. So this is just I'm showing you that here. So rest of the thing I'm just going to process over here. I will show you in the video. So here mainly we have the workspace. So workspace we can process satellite stereophotometric data, drone stereophotometric data, okay, and aerial photographs. All these three we can process in a same workspace in ArcGIS Pro. Okay, so let's see. So this is a new workspace under the imagery. So ArcGIS desktop, you will not get any kind of imagery tool, but here you will get a specific imagery tool. So even there is a sensitive image analysis tool is there. This is for the image processing only. So ArcGIS Pro is very capable software to do any type of things like from the deep learning to machine learning, then you can say LiDAR data processing, radar data processing, any kind of satellite image. Okay, so that processing is there. So I will show you in the last one of my channel links will be there. That is specifically for the image processing in ArcGIS Pro. So what are the capabilities will be there? So that I will show you. So that you can check there. So now if you see here, this is the workspace which is generated. Okay, so how to create a workspace? So this I'm just clicking over the new workspace. Okay, and you just see what will happen. So this is the workspace will come up. Now here you have to give a name. So what the project you want, okay, the project descriptions, and there only you have to select what you want: drone data, satellite images, and aerial photographs. So that you have to select here also. So accordingly, if you see here, I will just going to give this as a drone data analysis. That's a project name which I just providing, and you just see here. Okay, so see here, understand this. This is how, okay, just little go back and see here, whatever the sensor data types I'm just selecting now. So there we have three options for the satellite image, for the aerial photographs, and for the drone data. So for the drone, that time you have to select only the drone data image. That's all the things you have to do it here. So let's see. So I'm just going little fast forward. Yes, just see here. This is the drone, satellite image, aerial digital. Okay, so what the data products? That means all these three platforms you will capturing what? You are capturing stereo photographs. So this is the stereo photogrammetric technique, is a one technique to creating a digital elevation data, digital surface model, and orthomosaics. Okay, so this is the one process which is supported here, and there is some other techniques which we usually do in NV, that is called interferometric techniques in the radar. So that is a separate tool is also there, Starscape. Using that we are creating the fringe differences and we are creating a very high resolution DEM. So that is another process. In NV I will show you one more thing, that is called LiDAR data processing. So if you have a LiDAR data, from LiDAR data also we can directly create a digital elevation data. So that is LiDAR, from LiDAR to digital elevation data, from radar to digital elevation data, and this is the stereo photogrammetric technique to digital elevation data. Okay, so these are the three way where we can produce the digital elevation data. Another two way is there, that is from GPS and DGPS. So if you're simply taking the GPS, so there also elevation information is there. So using that, using the geo interpolation techniques, you can create a digital elevation data, and that will be more higher if you go for the DGPS. So DGPS will the most highest accuracy in the digital elevation data it is providing. Second is LiDAR. Third is SAR interferometric technique. Then it's stereo photogrammetric techniques, where you will get high accuracy of them. If you go in a research paper, if you search, then there is a very solid paper which is published, and it is comparing the results of all these three platforms, which is giving the highest resolutions over the digital elevation data. Okay, so that you can check out. So now here I'm just going to select it over the drone. So see here. So now same process, add data, and you have to add the folder. Okay, so same process, you just see here. So I'm just loading the same wherever I have my data, and see here. I will select the folder and all my data sets will come. So now if you click over this any one of the photos, so it will going to show you which photo it is actually. So now as of now we are actually creating the workspace. You will feel more complicated here than side scan. Drone to map is little complicated, it is more complicated. Okay, so that is the differences. So let's see these products. All the drone products you can able to see it here. Beautiful thing is you can process the drone data sets here also. It is complicated, but it can do that. Okay, so just see here. I will just creating the next process. Okay, so that is the informations you need to fill up, like which spatial resolutions you want, projections you want, that you just need to give. And then you can just simply start, go to the next and create a new mosaic map. Okay, so now once you will do this will take few minutes time. See, this is only getting a time. So loading and creating a workspace, it is taking time in ArcGIS Pro. Okay, but yes, you can process this data. Actually, I should show you from this, then only I should go to the side scan so that you can understand the easiest thing. Now what you did, you see the easiest one first, and now you can see this, so obviously you will feel this is much more complicated. Okay, but it is not like that. It is just what the products you want, accordingly you need, you have to go for it. So if you want to use for the multiple things, then you can go for the ArcGIS Pro. And if you want to work specifically on the drone, go with the drone to map or side scan. Okay, so that is the thing. So now here you just see here we have the data analysis. Okay, so long distance. Okay, so whatever, so whatever the processing will going to do, it will going to show you in the down. Okay, so now the same thing, if you see here, I will just going to little fast forward. So that is called bundle block adjustment. So here adjust tool, you have to do the manual options. So there you just see in the drone to map, there is on when I start processing, so the adjusting is doing automation, but here you have to select the adjustment manually. So once the adjustment will done, then only you can go for the next step. Okay, so you just see here, I will go little fast forward. See, this is the adjust. You have to give this command. There, drone to map, it is going in automation, but it is showing side scan, no need to think about it. Just click processing, all will start. Okay, so this is the difference of 3 softwares. Okay, so now here also you just see you have to select this. What is the focal length, principal? So this you have to give in manual options. And for that also you need a proper knowledge of these things. Okay, so that is a simplification in drone to map, where you need not to think about this adjustments. Okay, so that sensor adjustment, it is taking accordingly with the sensors which you are going to install in ArcGIS, sorry, drone to map or side scan. Okay, so that is predefined. So now that is work very perfectly. So here you can go for some little bit of manual interventions to process this data. So now I'm just going to show you this is a correction. So after the corrections, if you see here, you will then only you will able to see the images. Okay, so see now the images is loaded. It is not done actually. It is just loaded the image. So before that you can't see your image. But in drone to map you just see, if I click on add, so automatically all are adjusted and it will going to show you. So, but here it will take a lot of times. I'm still not giving in a processing. This is as I'm running it very fast, so you will not able to understand how much time it is taking. So you just see here the times are actually written, what for each processing, what are the times it is taking. Okay, so now suppose I'm just going little fast. Okay, so you just see from where. So after this now, so here you just see the top multispectral, DM, DSM and DTM. You can process it here. So whatever the products you want, you have to go each and one. Okay, and then you have to produce one by one. So that is the agent. So these are managing the GCPs. Like if you have some GCP points, same like drone to map, I just uploaded now, whatever I collected. Same thing you can do it here, but it is a little tricky. Just see here. So this is the GCP managers. You have to open it and then you have to run. You have to load those GCPs first here and then click on OK. Just see here. This is the importing GCPs. So here you have to import the GCPs also. Okay. So I just imported it. So then you have to give the spatial reference coordinates which you want, and then you can save this particular data. So this here. So if I click on OK, so all the data it will going to import in my GCP managers. Okay, so just see here. Yeah, so I'll just click on OK. So my GCP managers, those are actually uploaded. Okay, so then if I click on adjust, so accordingly it will adjust. And here, if I found any of the GCP is not matching properly, so from here I can select, right click and remove also. So that particular image. Okay, so that is that correction options, you have it here. Okay, so now if I see here, show you just a minute. So that is the present outputs. See, once you did the corrections with the GCPs, again you have to click the adjustment again. Same tool, adjustment. So once this adjustment results will come, if it is clear, then you can go for the generations of what products you want, DSM, TTM, or orthomosaics. Okay, so see here, this is a report it will going to generate. And now suppose I'm clicking the DSM. Okay, very fast products. So see here, so one by one, see ortho mapping. It will, you can go to the next. You can give the point clouds if you want. What is the size of this point cloud? So that also you can mention, and then you can go to the next again. So see here, this is the matching method, and then I can come to this. This is a DSM settings. Whatever, see, for each parameters you have to specifically mention these all things. Okay, so you have to know all about this information. So that's why I'm telling this is little more complicated. You require a good knowledge about DEM, DSM, so you can able to process in ArcGIS Pro. But in this case of drone to map and side scan, that those are very smart softwares. Okay, so there you not need to go for this much completion. See, if you are using in our time, that is we are using some Leica shoots, so then it will be much more complicated, because there we have to match the tie points and then only we have to generate. That complication is not there in ArcGIS Pro. So that gaps, after that it will come. So it is a big jump on that. And then ArcGIS Pro, slowly we are come to now in the drone to map solutions. So there we need not to go for any kind of thinking about the creation of this orthomosaics and these products. Okay, so see here, this is the DSM is generated. After that you have to generate the this also, and then we can go for the orthomosaic. So it will take a big time, almost 2.5 hours, because first it will create a DM, then it will give you the DSM, then you have to go for the orthomosaic and give run, then you will get the orthomosaic products. I will show you the orthomosaic information. See here, now I'm running for orthomosaic. So see, one by one at a time you can't run. Drone to map at a time creating all products. Another jump. Okay, here one by one you have to produce, so more time it will take. Okay, and side scan you already seen, means just a second you can not only process one project, multiple project you can run. Because of the data volume, nowadays data volumes are coming more. Okay, because so many drones applications are increased, so that's why the cloud computations is come to the picture. Okay, so that you can see in a Pix4D also, and in our case we are using the side scan. Okay, so you just see after this is the orthomosaic product. So if you see, this is a fast forward time that is also taking 25 minutes. Okay, and the full processing it is means so much time, it's like almost 3.5 hours times it is taking to get all these three products. But the good thing is, in one software, this is a multiple use software, means ArcGIS Pro, which you can use for the multiple purpose. So that is the advantage you will get it. So this is all about the drone data processing over drone to map, side scan, and ArcGIS Pro. Okay, so now we will move to the NV software, where we will going to process few hyperspectral data also, and multispectral data also, and how you are using the NV. What are the capabilities in NV? So first we will discuss few things on that, then I will going to show you the processing. Okay, so let's open the. Any doubts? Yes. Please ask. Yeah. Yes. See, vertical accuracy, see, usually we consider, say, 50 centimeter vertical accuracy we require, but it's depend on what level of the altitude you are flying your drones. Accordingly, your accuracy will going to generate. Okay, because drone we have a power to fly according to the altitude, we can create a depth. So then only we can get accuracy. This accuracy assessment we require more with whenever we are going to process the satellite data, because that is a fixed. So we have to cross check what kind of means satellite data accuracy, vertical accuracy or horizontal accuracy we require. But in case of drone, as we have our control in altitude, so accordingly the accuracy level will going to change. Okay, so that is the difference. No, it is not kind of fixed things. Like for, as I told you, satellite you can do this fixing because satellite altitude is fixed, but drone it is not fixed. So as the altitude will change, so your accuracy will going to change accordingly. So there is no kind of fixed things will be there. Okay, so that is overlap percentage. As I told you, we usually take it 60% forward lap and 20% side lap, but that is also depends on what kind of mapping we are actually doing. Some cases 22% also overlaps also people are using. Okay. No, 60% usually we give. Actually more if you go, then few of your area will not come. Okay, if you go for more overlapping. Okay, so that's why 60-20 is actually in general photogrammetric rules. This is whenever we are creating orthomosaic or them, usually we follow this rule. Okay, if you go and check any photogrammetric books, so there also this overlapping mentioned. But in some cases, we according to our project need, we are changing it. Okay, but if you are not getting good results in 60% overlap, then we can increase it. But usually this is a rule actually 60-20. Any more questions? Yes. Haze removal you are telling. See, yes, haze detections. See, haze detections we have a model in NV. Okay, but here you can't do any kind of atmospheric corrections things. Okay, so atmospheric corrections for, you will just see now I'm going to show you in NV. So NV we have but that power to do the atmospheric corrections. But in ArcGIS Pro, we have one kind of corrections that we call as a TOA corrections. TOA corrections you all know, top of atmosphere corrections you can do apply. Okay, but we don't go for any radiative transfer correction model like flush, or you can say that other Acron, that model will be there. So we can't apply it over in side scan or drone to maps. Okay, Pro you can go for TOA corrections, but that is for the sensor specific, not for all data. Okay, so other you have to go in a manual. Manual you can do the corrections, okay, using the raster model, or you can create a model builder, you can create a, but that is a much more complicated things. Okay, so best way you can go with NV. So there you have predefined models for the atmosphere corrections. But ma'am can tell better, ma'am, are you using hyperspectral atmosphere corrections over NV in your airborne data?
For airborne data, for drone, we are currently not doing it because we have a specific software to do that. But if we are, you're asking for other sensors, like we worked on Everest and Everest NG, yes. So for that software, for that purpose, we are using it.
Yes. So that means it's a sensor specifically designed for the atmosphere correction. Like whatever in NV usually we use, that is mostly for the satellite image. Okay, you will not, I am also not used for any drone data for atmosphere corrections in NV. Satellite data I use lot. So that is from Hyperon, Hyperspectral, and you can say Landsat, Moody's, a lot of things I did in atmospheric corrections in NV. But drone data still not, I'm didn't do it. Yeah. Yes.
Because that is very less
Yes.
so most of the times you are getting the atmospheric difference, but that's not that you get from the state of it, or airborne data which is captured from a very high orbit.
And another good thing is drone, mostly that time we are collecting drone data, that time mostly the atmospheric effects are a clear sky environment is there. Okay, so that time we are capturing the information. So there is a less use for this atmospheric corrections over that data. Okay, but in case of satellites, we don't have that power. There is atmospheric effect. Okay, so that is the reason at satellite data we can go for the more correction techniques. But yes, hyperspectral, if you go for it, then it is suggestible that you can go for the corrections because that is very sensitive. That is it. Any more questions? Okay, so we can start this one. Okay, so I will tell it, then you can now you can understand about this analysis part. Yes, sir. 5:30 is fine. Yeah, 5:30 will fine. 5:30 will fine, ma'am. Yes, I will try to be finished before that. No problem. It's fine. No problem. So now, see, this is NV is actually, you can say, is a powerful software to do any kind of image processing things, as you told about, like flush corrections or any kind of, yeah. Yeah, it's on. Share already has screen. Yeah, sorry. Okay. So NV is actually very professional software for image analysis. Okay. So I will show you few things like for NV, if you see, we can do anything like data analysis, and you can go for the, sorry. So can you please give the chart? Yes.
Which band of spectrum is available for disease detection in plants?
Yeah, I'm just telling, just charge में लगा देता हूँ. अभी बंद हो जाएगा. One minute. Yeah, can you please take this one? अभी एक्चुअली वो ही दिखाने जाऊंगा डिजीज वाला, तो बंद हो जाएगा, फिर खोलने में टाइम लगेगा. No problem. Yeah. So yeah, as is asking these questions once, like what spectral bands is identifying for the disease. So usually you can't say directly this answer because there is a different kind of diseases which you have to know. Okay, like sometime we are getting a water stress. Okay, for water stress we have a separate bands which you have to follow. Then some cases you have got iron stress or sulfur. Okay, so different diseases which will be there. So accordingly, for this type of disease analysis, from normal multispectral data you can't do the identifications. Okay, from NDVI you can get some idea, as you've seen. If you have high resolution images from NDVI or some thermal images, we'll try to correlate it. But for hyperspectral we can go for the pinpoint analysis, but you have to know there is different types of diseases there. So usually what we do, we are going with the some kind of paper, so which will be already did some analysis over some particular crop diseases. So that band combinations, the spectral range, we will try to follow that to target that particular disease. Okay, so as I told you that for water stress we are going to follow different kind of bands. Okay, so for I will show you now in NV. Okay, we will process the hyperspectral data. I will show you. So there we can create 27 different type of indices, 27 different indices, and using that you can see all the indices, you will find a different types of name. So that means that particular indices is identifying that for that particular stress identification of what that particular vegetation is. Okay, so that I will going to show you now. So then it will be more clear to you. So I think the answer will be fine. So let's see, let's start the analysis so that we can understand. So now if you see here we can do the data access, analysis, share, all these things, three things we can able to do it here. And we have some specific analysis over the NV. So first is, if you see like advanced spectral processing, okay, you can do the advanced. See, whenever we started any kind of spectral analysis, I found NV is the best software for that. Any kind of spectral analysis if you're going to do, so NV is always, it's a best software for that. Okay, so then image analysis workflow, you can create an image analysis workflow, which is earlier we used to do it model builder in some other software. Okay, so then here also you can start creating a model builder. Not only the bandmat tool is there, with that you can create a model also. Okay, so that is also another advantage you will get, so which will increase and faster your workflow in image analysis. Okay, so then some kind of robust ArcGIS interoperability, like whatever the model if you are creating here, so if you want you can take it in ArcGIS Pro, and ArcGIS Pro if you are creating some model, so that model also you can able to access in NV. So that compatibility is there. Okay, so then some program tools from the ideal also you can able to access in NV software. So these are the few types of specific data analysis which you will did in NV. So obviously the elevation data. So as I told you, elevation means DEM, DSM, DTM. So for that, here whatever we are doing this in ArcGIS Pro drone to map, here also you can do, but the photogrammetric shoot is required to creating this elevation. Okay, there is tool is called synthetic aperture radar. So usually we process SAR data. There is with this tool that is called SARscape. So in the SARscape, with the help of the SARscape, we are going to process the data over here directly, and we can create a digital elevation model. Not only that, means SAR, there is a huge concept, like one is the basic SAR data processing. Okay, so basic SAR data processing, usually like flood, urban analysis, we usually do it. Okay, so then with that, some advanced level of SAR data processing is there, like we have polarimetric data processing. So polarimetry is kind of a SAR data sending and receiving. Okay, so accordingly we have in SAR, we have this power capability to sending and receiving signals. So accordingly we have a different kind of image informations which is get in polarization. So that is sometimes we'll sending the VV signals and we'll receive the VV signals. So VV polarization usually told us. So VV, HV, HV, VH, like full polarized image we are getting. So this type of polarization analysis we will go for the polarimetric analysis. Some of that we call as an interferometric analysis. So interferometry, as I told you, that fringe differences we are actually trying to calculate the digital elevation data. Very recently, Joshimoto, you know, IRS is published one paper on that, and big controversies came, like they are saying this is sinking. Actually, it is true, it's sinking, but people are afraiding on that. But yes, how they did this analysis? Simply differential interferometry. So if you take an image, it's a image pair they're actually used. So before incident and after incident. Okay, so these two pairs, from these two pairs, there is, if you calculate the differential interferometry from the two paths, so that you can able to identify in that place how much it is shifted. And if there is any subsidence, that area also you can identify. So that technique is only they will be applied, and they calculated that, and they are giving some predictions over the large area in the Uttarakhand. So that the full process you can do it in NV SARscape. Okay, so this full process you can do it in NV SARscape. Now thermal data analysis. So any kind of thermal images. So what are the thermal images we have in satellite? I'm talking about, not this drone. Yes, drone also you can process. Thermal data means, suppose as of now, the best thermal data which is there now market, it is Landsat 8. Okay, and Landsat 9. So that thermal bands you can able to very nicely process in ArcGIS Pro. You can calculate the temperature, even for the MODIS also you can do. Okay, so all the thermal types of data, thermal data that may be from the satellites, maybe from drones, you can able to process in C. Okay, so then obviously the hyperspectral. Now here we will try to show you few data over the multispectral and hyperspectral, how this data is looking in NV, and what is the differences. That spectral curve which I drawed you now, I will show you now real. How we are going to show you that data, so that I'm just going to show you in real mode. Okay, so now next important thing is the LiDAR data. So here we have LiDAR data directly processed. That's a very good tool. NV is a very good software where you can do any LiDAR data. Okay, like that is from Airborne, satellite, it will create DEM, DSM, DTM in a automation. Nothing need to do. Same thing like ArcGIS side scan you see now, you just stick on and you just click OK. Same thing you have to do it here over the LiDAR data. Okay, so if I have one video, I will show you. So now I'm just, there is a aerial data, so photogrammetric image you can able to create it here. So now this is some kind of called as a extension tools is also there. So what are extensions tools are doing? So like if you want to do the photogrammetric analysis, so that maybe for you can say the moon data sets also. Okay, so that is possible to do. Okay, so if you know that PDS, there is one center, you know, PDS is what? Planetary Data Service. So you can download any moon data, Mars data, and you can very nicely process in NV. Okay, not only NV for the planetary, NV is also used. You will very astonished. I went training. One is in Jagadish Chandra Bose Institute of Technology. They are using this data. One is for the planetary science. Okay, so as I told you, this is a planetary science they are using, and for the astronomical analysis also. So there is a different type of stars and constellations. If you see here, all stars are different color. So that is actually a spectra. So their spectral analysis they are actually doing in NV. Okay, so that work also is done by there. That is a Jagadish Chandra Bose Institute of Technology. Not only that, there is one institute I went for the training, that is ICMR. Okay, it's a medical institute. So they are taking scanning of your bodies, and where there is a high temperature, they're taking images with the different sensors, and why that particular area is showing very high temperature. So that data analysis they are doing, processing it in. So it's a huge applications area, any kind of image analysis. So you can understand. So what kind of a image analysis we can do it in. It's a very strong tool. Okay. So now, so there is a common link between this NV and ArcGIS. So any data, if you want, you can directly open from NV to ArcGIS and ArcGIS to NV. Okay, so that processing is very faster here. Okay, so now if you see here, we can build different kind of work like visualizations you can do, monitoring agriculture health, detection of anomalies, count of the trees. You know, there is a specific tool for agriculture we are using here, that is called crop analysis tool, that is basically used for the precision agriculture. I have one good video recording is there in YouTube, I will provide you. So crop analysis tool is actually used for the precision agriculture. So using that, you can identify which crop is under stress. That is also over the two types of products, like for the horticulture crops and for agriculture crops. Both we can identify using the crop sense tool. Okay, NV crop sense tool. So like that, we have the spectral identity. See here, this is spectral curve. Okay, you just see, I think it is not coming properly, but this spectral curve, how it is creating, it is called as a spectral collections. I will going to show you now. Okay, so now this is some data sets we are going to use of the hyperspectral data. So I am telling you a few differences between hyperspectral and multispectral, then we will start totally the processing. Okay, so hyperspectral data, as we know that we have hyperspectral remote sensing, takes a remote sensing era to picture to era of measurements. So multispectral, you can see and observe the informations, like if it is vegetations, it is urban, it is agriculture, you can tell. But within a vegetation, what is the type of the vegetation? You can't tell. Hyperspectral is giving you that options. Okay, so if it is a vegetation, then it is a pine tree, or it is any other tree, banyan tree, whatever it is tree. So we can identify using the spectrum. So that is the power of the this. And now this is the differences. The same picture which is drawn it here. You will see here multispectral, it's very same spectra. Okay, it is created in multispectral. See, this is the image which I just going to show you. This is the IRI data. One is the hyperspectral, the same plot which you just seen here, and this is a multispectral. But see the differences. This is a vegetation curve usually we found, and this is the how the multispectral images will be coming like, and how will creating this spectra, that only I'm going to show you. So tomorrow maybe you will going to take a total hyperspectral analysis, so then you will get a much more idea on that. But as of now, the basic things first you have to understand. Okay. So now that hyperspectral, multispectral, the differences you understand. Why this curve is coming smoother? Because it is coming the value from the more bands, and using those value we are creating this spectral curve. So that's why it is much more clear, which is not much more clear in this. Okay, so that is the differences, and you can get some much more differences in multispectral data. Use the detect existence of the various materials, and hyperspectral you can allow only the identifications. So that is the advantage of hyperspectral. So let's start the demo. Okay, so that it will be much more good for you. So I am on, switch on the NV first. So that is this. So let's open the NV. So this is the NV tool. So first thing, whenever you start and open the NV, that is, you have to connect your data folder by your work folder to your NV. Okay, so that we will fixing with the preference. Just see here, if you go in a file, here you have a tool, it's called preference. So okay, so I'll click on that. Here we have options for the direction. Okay, and under this we have the input directory. Okay, so I'm just simply click on the input directory, and wherever I have my data, so I'm just going to select that. See, under this IRI samples. Okay, so I'm just going to select a hyperspectral first suppose. Okay, so, or you can say IRI sample, I'm just click, that will be better. So all data I will get in a one folder, and whatever the data processing I want to do, I will just save it in the test2 folder. So I'm just click on OK. So what is the advantage? You know, if you click now this open folder, so directly it will open that particular folder where I have my all data sets. So this is the first thing which you have to do, that is the connectivity between your folder. Now I am just going to open a multispectral image and one hyperspectral image, and then I will show you side by side how it is looking like. So very first I'm just going to open the hyperspectral airborne image which is flying here. Okay, so this is the hyperspectral data, and this is the data which is the hyperspectral, and I'm just simply click on OK, and you just see here now. So this is the image. Okay, very first image. So this we called as adjustment tools. Okay, so here if you click on this particular tool, it's called zoom to full extent. If you click on that, you will get the image like this. So what is the band combinations of this? You know, what is the band combination? What types, this type of image, what we call? Anyone? What is this band combination? It's true color band combination. Okay, true color band combination means, what is the band? Anyone? Any idea? RGB. What we call as a true color band combination and false color band combinations. What is the false color band combinations? Any idea? Very good, very good. Okay, so NIR, red and green. So that is my false color. And this is the image which you see, that is the combination of blue, green and red. Okay, so this thing, it can control in automations in a data manager tool in NV. So just see here, if you don't know what she said, that the band infrared, red and green. So now you will see what is the confusions here. You just see here. If I click over this data manager tool, so now I giving you 200 bands and now telling you create a FCC or a true color composite. So what you will going to do? Usually for the satellites, I'm telling you. So you have to know. Anyone can explain? If I'm giving you this task, so you have 200 bands and show me this image in false color composite. So how are we going to do it? I'm not talking about now software. Just simply tell me from these 200 bands, how can I will identifying which one is infrared, which one is red, and which one is green? How can I will tell? Any idea? Which what? Tell me from here, what is there in this band from where we can understand which one is blue band, which one is red band, and which is green band? Any idea? Huh? Exactly. This is the answer. Okay. So no matter whatever satellites you are actually using, your main focus is spectral range. And this is the thing. Okay. So you should know which band spectral range is falling under blue, which is falling under green, and which is falling under red. So if you don't understand that, then you will get a confusion. So most of the people I've seen people are mugging up for the which satellite, what is the false color? Landsat, okay, 543. Landsat 8, 543. Landsat 7, 4432. Don't remember like this. Just think about what is the spectral range of that particular band. Okay, 4 to 7, 4 to 5, 5 to 6, 6 to 7. We know this particular range of the electromagnetic spectrum. So accordingly, you have to select. But now, this is for your knowledge, I'm telling. Okay, but the software is very smart. Okay, now see how this software will work. So you need not to do search anything. So just need to right click and click on this color infrared. That's all. Understand? And see, automatically the spectral range also changed there. So whatever it is picking from your blue, green, and red, it will automatically doing from that particular bands. So that is the means you can say smartness of this particular software. You need not to think about which bands of this lot of hyperspectral image, which is the infrared, red, and green. And this is very important here. Okay, so see here, as I'm just opening one image, if it is a multispectral, so then we don't have to think of anything. We can very easily open it. Let's open the hyperspectral image. So I will make in a two different window. Okay, so here how we'll do it. So you can go in a view, make it two vertical views, suppose. And I'm just simply click on this. This I'm just trying to open, and I will open the same map over now multispectral. This is a TIFF band. Okay, so simply click on OK. Okay, so this is your multispectral bands. So as these two are not, you can say not geolink, means because two are different spectral means projection system. Area is different. Okay, so that's why it is not exactly will match, but a few part of that area is actually common. So why I'm trying to show you that? So that is basically we called it as a link view. So same thing which I showed you in ArcGIS Pro, two window linking. So same thing we usually do it for this also. Okay, so say we have very less area which is coming common. But anyway, our main focus is not to show that. So our main focus is to creating a spectral curve. How we are going to create a spectral curve. So that we will trying to show you over here. So just a minute. Yeah. Okay. So now usually we compare this over the same kind of images, but as of now I'm just trying to show you a multispectral curve and a hyperspectral curve. What is the differences? Okay, so whatever I showed you by the drawing, now over the image I'm trying to show you that, and how we can draw the spectra. Sorry. So how can we create a big spectra? So that we will try to do it here. Okay, so now if you see here, we have, this is called spectral profile. I think why it is coming now, it is not able to remove now. Okay, 1 minute, I will just make little down. So this is, if you see here, this is we called as spectral profile. So whatever window you will select first, so that particular spectra it will going to create. So first you see the the multispectral spectra, how it is looking. So if you click on this now spectra, so as it is coming this, so here no spectra, so now it is spectra. Understand? So this is a hyperspectral spectrum. Now you see the hyperon, means not hyperon, sorry, hyperspectral spectrum. So usually we are using that particular satellites whenever we are using hyperspectral, but now here it is a very good data sets. Okay, so I'm just simply click on this spectral profile and see this. Okay, understand? This is the spectral differences. Why hyperspectral we are getting much more smoother? Because we have more number of bands. But in case of multispectral, you seen only few bands are there. So that's why these differences is coming. Understand? Na? So why whenever you are talking about any kind of stress of over vegetations, how will you going to understand? You know, it is not an easy task. You have to know what is the peak and what is the dip. For some specific disease, you have to know what particular spectral range it is going deep or peak is coming. So you have to know about that knowledge. So then only you can go for that kind of biophysical parameter estimations to identifying any kind of crop disease or something. Okay, so we will going to tell you few things about that. But here, if I am just opening a same band, one is in true color, one is in false color, side by side also you can open and you can see the same thing over here also. As I just, time is short is there, so I am just opening the two things over together like multispectral and hyperspectral, and then I just try to show you the spectral differences. What is the called is the spectral differences. Okay, now the next thing which we're going to show you over, that is the, you can say, a kind of indices. Okay, so first I will just close these all things. I will make it a single view. Okay. And same over, whenever you have this, if you want to open your map in true color, simply color infrared if select, automatically it will come in color infrared. You need to select manually for the selection band, so that you understand, I hope now. So now the next thing which we're going to apply it over, so that is the vegetation indices over the hyperspectral data. So whenever you have vegetation indices, so that you can run it here. So this is called vegetation indices calculator. See, vegetation index calculator. Okay, so this will work only over in hyperspectral data whenever you have. Okay, because you have multi number of bands. So then only you just see, if I select this multispectral data, if I click on OK, see all these are different types of indices which you can able to calculate within a second. Okay, so you see enhanced vegetation indices, atmospherically resistant vegetation indices, modified ranges, simply verified indices, some green indices. So like that, you have to read all these descriptions is there. Okay, so each for the plant, okay, red when there is a water band index. Okay, so there is a different kind of indexes will be there, which we are actually identifying out for the different stress. Okay, so suppose there's a 21 different kind of indices which you can create within a second. So you just need to click on this memory. Why I'm doing in memory? Suppose you want to testing it. So once you do the testing, you need not to create output. You just see the output first, and if you feel okay, this is fine, then you can save this output also. Okay, simply click on OK. So this is our hyperspectral. It will take few minutes time, and then you will get the results of all the 21 different indices. What you usually do, we have to open the each and every indices in a separate window, and you have to create a color composite over that. I will show you how to create a color composite. I have no idea how much time it will take. Otherwise, I will open a new window and I will just tell you the process for how we are going to create a color indices over it. What is the color indices? First, I am just telling you. So whenever you have a single band image, okay, so there is a two-way to do the color applications. So color applications is a two process. One is we are giving a stage value, okay, and we just see where is the high value, where is the low value. That much we want to see. We did not want to see any changes over this. Okay, another one is the range of the spectral value. Means a single bands, it will going to give a indices. So what are the indices value is coming? Indices value is coming between 0 to 1. So whatever it is near to 1, that is your target value. What is 0? So that is a negative value. It's non-target object. Okay. So if I have this indices band of this, so what you have to do, you have to create a spectral color. You can use color slicing. This we call as a color slicing. So color slicing, what it is doing, so single band image, it will be classified in a range of the spectral means indices, so that you can understand which one is the high, which one is the low. So in the crop, okay, that particular means indices will going to show high in what particular place. So that thing you can see it here. I will show you that what file which you have as a training PDF is there. I will give it to ma'am, so you can do this hands-on once you have time. So I will show you the result there, which is with me. So by the time it is going to process. So this is the training manuals. So if you see here, I'm just showing you, this is the hands-on PDF. You can go with this. And this is the spectra, how to create a spectra, which you will get it from here. And this is the thing. See, this is the indices which I just run. And see, this is the results. Okay. So you see, I have this. After this, we have to open. See, it will create a single band, means one image it will going to create, which have 10 different bands. Sorry, 21 different bands, means 21 different indices, 21 different bands you will get. So what you have to do, you have to open, like now we are opening 2 by 2 window. You have to open 10 window together. Okay, and you have to load all the different indices. And then you do the geolink. And then trying to compare one indices to another indices, how it is. So whenever you are opening the first time, it will be a black and white image. You just see here, this one is a black and white. So you have to open in a black and white, and then you have to right click and you have to go for the density slicing and click on OK. That's all. So you will see the color image. So here you just see, if I little zoom it so that you can get an idea of the image. See this. So where is the part of that particular agricultural land is under stress? Okay, so that you can identify with the different indices, different. So that you have to interpret. So that is a challenge. Okay, so why it is coming high, why it is coming low. So that you have to give a proper explanations from your investigations. So this same technique we applied our multispectral data, or not multispectral, in hyperspectral also, and another technique is there that we called as principal component analysis. Okay, if you heard about that, principal component analysis, also we are generating 10 bands. For the first 10 bands, it will give you maximum number of informations over your images. So there also you will get an image something like this, from where you will see something which is not usually visible in your normal eyes. Okay, so that over that also we are going for the investigations, and here you can run principal component analysis also very nicely over the hyperspectral data. So only thing is, if you see here, it is taking little time. Okay, so this is the process. Okay, it's almost done. So this is the process of hyperspectral data, how we are actually process the indices over here. And there is one more techniques which we told it about. See, this is the, that is called how we will collecting this spectra. Okay, so I will open one more NV so that I will show you how you collect this spectra now. This is called, we call as n members. Okay, how we will collecting this. So as of now, what I showed you, only the spectral curve how we will create. So the next steps is, you have to preserve this spectra in your spectral library. So that I am going to show you now. How to open a hyperspectral image, how we'll create a spectra, and how we'll save this spectra in the spectral library. So let's see. So I'm just going to open the same map. So this is the image. We all know. So I'm just right click, color infrared will be better. I'll remove this one. Okay. So now here, what I did, see, up to this, you know, like how to create a spectra, that we showed you, but still I am showing you again. So this is a spectra. If you click over this, you can able to see if I take this spectra over this no crop area, you will see the spectra like this. But if I go over this particular crop, you will get like this. And if you go this side one, see, this side one is something different, and this side one is something different. Okay, so just think about all our different crops. Okay, so we are collecting that spectra. So what we are actually doing, see here, if I first collecting the first spectra over this, so here we have this option. Are you see there's some small arrow? If you click on this now, so it will extend up. Okay, so if you want this, then shift and click. See there. Are you seeing something here which is added? So this you can give some name. So if you come here, you can give some name as like crop. Enter. First spectra is collected. Understand? Now the next spectra we are going to collect. Suppose I am just going to collect this side spectra. Now you see the change on the spectra. You can simply click over this. See, second spectra came. So I can give a name something. Oh, so many times if you click, so it will come like that. Don't worry, you can remove one. Yeah. So this is my another spectra which I collected. So I can give a same name. Suppose side area 1. Okay. And you can collect one more spectra here. And that also you can give a name, something like this. Okay, so you can give a name side area right. So this is we called how to collect the spectra, or you can say in member. So now you have to save this in where spectral library. Okay, so how will do that? So here you have options to save this in your spectral library. Okay, I can click some name, click on OK, save in spectral library. So now there is a two-way to do the classifications. Okay, so usually over multispectral image, you all know about these techniques which you call as a supervised and unsupervised classification technique. Okay, but whenever you have hyperspectral data, so I'm not going to run it because it will take so much time, but the process I'm just telling you, that is this, whatever we are spectra we are collecting, using this spectra we can able to classify the informations. That we call as a spectral angle mapping classification. So what we did, we are collecting the pure spectra, we create our spectral library, and using this spectra we try to classify the image. Okay, so this is over the hyperspectral image, mostly we go for it. Okay, so these techniques we called as a SAM. It's a very famous technique for the classification. So many classification techniques is there, as I told, supervised, unsupervised. Now this is a SAM. But in supervised or unsupervised, if you see in ArcGIS, sorry, in NV, we have a new, you can say, development which is called as a classification workflow. So classification workflow, what it is doing, suppose if you want to do the classifications over any this hyperspectral or multispectral image, okay, so then you can simply run this like classification workflow. You just need to give a input. So now there only you have options what you want to run, supervised or unsupervised. So if you select unsupervised, so then training data is not required. But if you select the supervised, so you have to create a training data. So that workflow I will show you, and the SAM also how you can run. So that also I will going to tell you the process. Okay, because if I run the process, it will take some. Just one I already run, so it is still not finished. I thought to show you the all steps, but I will, means this processing time is very much, it is taking very much. Okay, so now you just see here. So this is usually we call as a spectra. Okay, so if you close this, spectra will go. So now you can open the spectra from here also. If you want to open it, you can open it. I forget where I save this spectra. Just a minute. Test 2. Yeah, no, it is not there. Okay, I have one spectral library file. I'm just trying to show you that. Okay, so that is better. Just to show you how to upload the spectral library file. Okay. Yes. Not this one. Yes. Suppose. Okay, so this is suppose the spectral library file which you just saved now. So that will become as an extension as a SLI. So if you need to click on open, so that spectral library which you created, so that will open up. And this is the spectral library. And this is the spectra which you just collected and save it. See, actually during the saving I should check which folder I am saving, so I not observe that, so it will go somewhere else. But anyway, you have to open the spectra which you collected like the same way which I showed you last steps. Here, this is we call as a plot window. So what we did, so whatever the spectra I want to classify, okay, I need to select one by one. That's all. And over which image I want to apply, so that image I need to open it here, not this one. And here now you have a tool is called SAM, spectral. Okay, so if you search by the spectral, so automatically it will show you the spectral angle mapper classifier. Are you able to see it here? So this is the spectral angle mapper classifier. Okay, so you need to give input of that particular data which you collected this spectra. I'm not collecting this spectra from here. So then you have to click OK and see here import. This is called plot window. So because my plot window I opened, so I can click on this plot window. So whatever it is there from the plot window, it will come up here. Okay, and then we have to click on apply and then classify. So from using this spectra, it will classify the full image. This is the techniques which we called spectral angle mapping classifications. And creating a spectra, you've seen the creating, how to create a spectra, then how to add or save the end member in the spectral library, then how we'll recall the spectral, your end member which you saved, how we recall it the spectral library again, and how we will plot it in a plot window, and then using the plot window, how we'll classify it. Clear? Any questions up to this? Anyone? Yes. Yeah. Yeah. Mixed pixels you are talking about. See, usually whenever you have this type of high resolution images, okay, so we are taking the spectra which is over the pure area. Either you have your spectral library which you are using the spectrometer, using that you are collecting. This is the process I'm just showing you over directly over the image how we are going to do. But to taking it, we have our GCPs. So using the GCPs only, we are creating this spectral library. If you've seen, using those GCPs, we are creating this spectral library. Okay, so there is a less chances of the mixed pixels over that particular. So that is actually the process. Otherwise, you have your spectral means spectrometer. You are collecting data from the field, same area GCP points you are collecting. We use that point for the creating our own spectral library. This spectral library, if you've seen, so that you can import from your spectral library data which you are collecting from using the spectrometer. So that also you can do, and that also you can use for the classification. Okay, any more questions? That I have no idea. She is there. Oh, where is she? I don't know. She is in call. You can contact her. Okay. Any more questions on this? Yes, yes. Please let me know. Huh? Yes. A little loud. Can you please little loud? Yeah. Yes. Yeah. So what is this spectra, This is reflectance only. Yes. Yes. A particular wavelength reflectance value, it is only showing, you just see here. Oh, Excel table you are saying. Yes, you can do that. You can do that, but there is no direct tool here, I think. Yes, ASCII file format you have to save. Yes. Exactly. So you have to take it in ASCII format, right? Yeah.
Is it possible to create the spectral library for entire image? We are taking specific pixels which we
Yes. We usually take it for the specific pixels. Inter image, sometimes some kinds of data sets are there which we can convert directly totally in ASCII files. That is also there. But over this type of hyperspectral huge data, we never do these things. Okay. But we did this type of work over time series data, and that we can directly convert it in ASCII files, and we did analysis there. But hyperspectral, this much heavy data, we never tried. Any more questions? Okay, so one last things which we're going to show you, that is the classification workflow. So one workflow I showed you, that is the SAM. Another one is, you can see here. Okay, I think that is ready. Yes, this is ready by that time. This is, you know what, you just see here, enhanced vegetation indices, simple ratio, and normalized defensive vegetation indices. 3 bands are there. But how you will open it? You have to go to view, and you can make it 3x3 or 4x4, whatever you want. I just going to show you 2 or 3, okay, so that you can get an idea. So how we usually upload those indices bands, and we are trying to compare. Okay, so here this is already there, so anyway we leave it, and then we come to this and go to this one and see here now. Okay, so here you can select and load back, that's all, and you can click on this, and this load band, you can right click, go to the change color table, and this is a ring. This you will not get any spectral range, but the same thing if you go and do it here like this, because that will take a large area, so that's why I'm not. It's called raster color slicing. So another I will show you with the color slicing, so that you can get an idea. It's not good data. Yeah. So this you just see, right click, if you go in a new slice. So which band is red edge normalize, red edge normalize, select OK. So now you see a difference. Okay, you will get a spectral range. So accordingly you can make it also. So there's a 2 process. Either you can go with this, or you can go with ring. Either you can go for the spectral range, or you can go for the ring. Rainbow is just to show and compare. There you need not to go for any kind of spectral range. But whenever you are doing the slicing, so slicing, density slicing techniques, if you heard about image processing, then you know. So density slicing is just taking the clustering over the pixels, and it will classify the image. So that is we call as a density slicing. So this is how it is done. So this is over a different bands of indices, which will created over the hyperspectral image in a one shot. Same kind of things which we can do it over the crop science analysis tool also. So crop science analysis tools, we have lesser bands. So lesser bands, over the lesser bands also, we have 250 different types of indices which you can avoid. Use it. Here 21, there it is 250. That is crop science analysis tool. That is a different NV tool is there for that. Okay, so this is the process, and I just telling you the one more thing, that is of the workflow, like classification workflow. Yeah, so this is we called as a classification workflow. So I'm just going to show you that, 1 minute. So this is the classification workflow. So whatever the image, I'm just not going to run, I just showing you the steps. Okay, so this is the image you need to give the input. Okay, so then see, workflow means in a one place you can run the total. Okay, so here this is the training data and no training data, because I'm going for the unsupervised, so I will go for the no training data. Okay, simply click on next. So number of the classes, whatever the classes you want, you can give accordingly, and then simply click on the next. So see, this workflow is actually running and it will going to show you here. But after the classifications of these, we are doing the aggregation. Aggregations means some kind of pixels, means whenever it is a 5 classes also, you will see there is so many of noises there. So that aggregations also you can update over here. And you will, once you will get the final output, then only click OK, and you will get this full image in a classified. Okay, in a 5 different classes. Again, see, it is taking time for the, because workflow is, see, I can go for the manually I can classify it, and then I can go for the next step for the aggregation. And workflow is in a one place, all this work will done together. So in NV, you will find so many workflow tools. Now for the classifications, we are using this type of workflow tools. This is one which is for a classification workflow. There is another one which is called change directions workflow. So if there is 2 image you have, 2 time size image we have, and classified image you have. So using that workflow, whatever the changes is happening, so that also it will extract, and all the statistics it will calculate automated, and then it will give you the results. Okay, so that is the process of the workflow, how the NV workflow it is actually working. Okay, so by the time it will run, I'm not going to run the full process, because this classification it will take a lot, because it's a hyperspectral data. So the last thing which is there, so that is the subsetting which we do over the hyperspectral image. There's 2 kind of subsetting we usually do. One is the spectral subset, another one is the spatial subset. So what is the spectral subset, you know? I'm just going to show you that. Okay, so I will take, suppose, one value, one view. Yeah. So now if you see here, if I open this data manager, so over this you have, better I will show you over this data, hyperspectral data. Suppose we have this hyperspectral data, and you see we have many bands. Some cases we used to remove the noise bands. Actually there is a procedure will be there, like MNF, in dimension visualizer. Okay, then pixel identification, then we can go for the SAM. That is actually proper way. Okay, because that is how we are processing the hyperspectral data. But here, so whenever we are running the MNF we call as a minimum noise fraction. Okay, so that is whenever you have a noise bands, you can remove the noise bands. If you know what is the range of the noise bands, we can remove. Usually Hyperon, there is a lot of noise bands we will found. Okay, so that in that case you can removing or resizing your data sets. Okay, so I'm just showing you one that we called as resize. Okay. Yes. So this is we call as a resize the data. So if I go in a hyperspectral high XC data, okay. So you just see 2 types of subset you will get. One is spatial subset, another one is spectral subset. So spectral subset is what? Spectral subset only, I'm just explaining it. Like suppose I don't want those bands. So if I go in the spectral, so you see it will going to show me all the spectrum. So suppose I'm going to take only from this to this much spectrum. I will take this shift and I will take this much spectrum, suppose. So 41 bands I selected. I don't want all the bands. So this much bands only I want is, I know this is the good bands and I'm going to work with only those bands. So this we call as a spectral subset. And this is required whenever you are using huge data in hyperspectral, like a lot of bands. Why? Like one person is asking the questions now. I want to identify this particular disease, suppose. And if you know this disease, whatever you are targeting, it's only required this much bands for the process. So then why you are taking all the data? Why you are taking all the data? Because if you are taking all the data, just see the processing time, how much it is taking the processing time. So it is for the pinpoint of your working. So if you know this much band is required for your analysis, then you should go with those bands, no required for the other bands. It is not like that the satellite data mein sare bands are right, we have to go for all the bands we have to take in processing. Even though satellite data also we are not taking. Sentinel nowadays 13 bands are coming. So can we work with all the 13 bands? No. We usually take the multispectral bands, whatever we have. Same here also. Whatever the required bands we required for my analysis, I will go with that. So this is the process. If you click on OK, so now the spectral subset is ready. Even for the spatial subset also I can do. Suppose how much area you want to cut. So either you have one shape file of that particular area, or cut image is also for that particular area. You just see here, if you click on, so this is a spectral subset, we are already did spatial subset. So three options, either image, file, or ROI files. You can create ROI files, how much area you want, you create ROI, and using that ROI you can collect. So how to create ROI? You just see here top, this is the ROI files. Options will be there. You can create ROIs. ROIs is just like a, suppose the shape files, how much area you need to cut. Save the ROIs, you can load the ROIs from here and then click on OK. So I'm not doing spatial subset, spectral I'm just going to show you. Okay, so this is fine, click on OK. So I'm not going to save it. If you want to save, you can give some name and you can save. Otherwise, you can go into memory and click on OK. And see when the new, whatever the memory 2 will going to create now, you just see it is not there all the bands. It has only 41 bands. Understand? This we call as a spectral subsetting. Okay. So one is spatial subsetting, one is the spectral subsetting. So spectral subsetting is required because whenever we are dealing with the multiple bands, so all bands is not required. So whatever is my study, so according to my study, I know which bands are sensitive to my work. I will take only those bands, I will remove all the other bands. So that is the way of the processing work you have to follow in this. So it is still taking time because of Hyperspectral. So that's all from my side. So if you have any questions, please.
There is one question.
Yeah.
How do we get the ground truth and how we can use it for SAM?
So ground truth, basically you required a spectroradiometer, okay, or spectroradiometer you have to collect the same thing like spectral, whatever we are saving it here. So there in the spectral library, once you are collecting, so there also you can save it as a seal file. The same seal file you need to upload it here, and rest of the process is the same, whatever I am just showing. Any more questions? Okay. Thank you. Yes.
Snap tool
Huh.
for the SAR processing, the graph filter is there. Is there
Snap. Okay, graph feeder. SNAP you are talking about. Okay.
So is there any functional traits in the NB?
Graph tool means
Like
spectral curve. Means that
process automated, we can automate the processes.
Yes.
Like apply orbit files.
yes, yes. See that what we are doing. Graph tool is same. Yes, yes. Model builder only. Yes, here also it is there. You can create a model builder here also. Same. Okay, graph tool you are told. No, I understand now.
Drag and drop or we have to
No, just drag and drop. सेम लाइक ArcGIS Pro में जैसे करते हैं ना, ड्रैग एंड ड्रॉप करो, इवन यू कैन क्रिएट अ मॉडल इन ArcGIS Pro, ओके, एंड वो मॉडल को भी आप इधर यू कैन यूज इट हियर आल्सो, एंड यहाँ पे भी कोई मॉडल बिल्डर है, वहां पे भी आप मॉडल बना कर सकते हो, एंड दैट यू टेक इन ArcGIS Desktop, ArcGIS Pro both. So that is the advantage here. Okay, so he is talking about like अभी जो process मैंने दिखा है ना, so one by one we are actually processing it manually. So you can create a model and you can run in at a time. So that advantage is that model, suppose if you give to another one, so they can also use that particular model. So that sharing options you have. Other place you create a model, but that is only with you. But here advantage is, as it is a connectivity with ArcGIS Pro or ArcGIS Online, so you can take this same model in ArcGIS Online, means ArcGIS Pro also, and there you can create it as a tool and you can share it in ArcGIS Online or ArcGIS Enterprise, so you can share with anyone in the world. So that is the model builder, how it is helping. It makes our workflow faster. And ArcGIS Pro, there is another important thing I just told you. It can create a model in automation also. Here, manually you have to create a model, NV. But ArcGIS Pro, suppose I'm doing a hydrological model. So for hydrological model, there is a certain steps. Like we have to do the field corrections. After field corrections, we have to go for the flow directions. Flow directions, then have to go to flow accumulations. And then flow accumulations, we have to extract the reverb. So manually, one time if I process, okay, so whatever I will process now, so it will store in the history. The geoprocessing history is there, and that is for the raster image, the raster history is there. So if you go for the images from the raster history, if you just right click and select add to the model, so all the processing we are doing now, it is creating a model builder in our automation. You need not to go for any manual, and then you can run the model again, and you can save the model. That is options. So that is automatic model builder creations. And from automatic model builder, if you want to create a Python code, so there in Pro only there is one options, convert the model in a Python code. So you can convert in a code also. So both way is there. Okay. Yes.
Thank you very much, sir, for
Yeah.
the valuable information.
Thank you. Thank you very much. Thank you very much. Okay, I will stop this, otherwise it will go on. So user manual is there. I prepare one PDF for the training. Data is with ma'am is only there, so you can practice this also in any. Thank you. Yes. So I'll stop the sharing. Yeah. I'll leave the meeting. ना? मैं leave कर दिया. It's fine. में लगा क्या कहता है एकदम चार्ज नहीं है. Yes.
any doubts, software related doubts if you're having. And I would like to thank Surya sir and Arushi for being here with us and
Yes, yes.
delivering so much information, just like hyperspectral data.
Oh.
So I would request Dr. Rajiv sir for special meeting the guests.
This lecture almost over. Tomorrow by 9:45, there will be practical and lecture both combined session will be there. Mostly the spectral radiometer, the working principle and data collection and their analysis with and FTIR, the company person will come and you must state how data collection will be taken and their analysis. So tomorrow whole day the spectral radiometer, FTIR, microwave, MIR